Ladies and gentlemen, welcome. The reason you see me for 2 sentences is I'm heading the economics group within this Academy of Sciences. And I would like to just give you 2 sentences, because the credibility of empirical research is extremely important, particularly in this period of alternative facts. And we have had 2 of our members in this section, economics, in this Academy of Sciences, that put together a program on the repliceerbaarheid in Dutch, the replicability in English of empirical research. And by far, for me, the most interesting thing is we do this across disciplines. And I think that's another important thing of the Academy of Sciences, to bring different disciplines together to learn from each other. So I welcome you. If you have questions in the afternoon, keep in mind that at the end there's a panel discussion. And with the panel discussion, we also open the floor to the audience. So if there are really questions that you have, wait for the panel discussion. If there are just things that you just don't understand, clarification, in a very modest way, try to interrupt speakers for clarification. But there is a panel discussion for more fundamental discussions. I hope you enjoy it. And I would like to give the floor to one of the 2 organizers, Philip Hans Francis. And obviously the other one is Albert Menkveld, who you will see later this afternoon. Philip Hans.
Welcome, ladies and gentlemen, to this symposium here at the Royal Academy. Welcome to you all that you came to Amsterdam. We have a very nice set of lectures. First, 3 speakers before we have a break, and after that, the keynote and then the panel discussion. But first, I give the floor to Anna Dreber from the Stockholm School of Economics. Thank you.
Okay, I'm Anna Dreber. I'm super happy to be here. Thanks so much for coming. Thanks for inviting me. Very nice to meet some of you in person. I worked with Albert for a few years and had never met until today. So lots of fun to be here. Okay, so I'm going to talk about replications and uncertainty. So I'm going to cover a lot of material in a short amount of time, as we're all used to. If anyone wants to talk about any of this at some other point, let's set up a Zoom meeting or talk more today. Okay, so I'm going to start with an example of how things can go wrong. So this is a study that was published in 2009, where I was interested in individual variation in risk-taking. So that's a topic that many behavioral economists, psychologists, and others would be interested in. In this particular study, we do an experiment with 100 men. We look at their risk-taking from an incentivized gamble, and we take a DNA sample of these 100 men. And we genotype it for 2 specific dopamine receptor genes. So dopamine is the reward system, so one could think that this is going to be related to risk-taking. And this was at the time when genotyping was expensive, so we could only afford 2 genes. We report the results for both genes in our paper. One has a null result, so that's not in the title nor in the abstract, but it is in the paper, we don't hide it. But with this other gene, DRD4, we find that those with the longer version are statistically significantly more risk-taking than those with the shorter version of the gene. So that's the title, that's the abstract, and that's what sort of made me super excited and made me spend many years chasing this problematic result. So here's the figure. What's the problem here? This is statistically significant. It even survives multiple correction tests for 2 tests. So what's the problem here? Anyone? No power. There's no statistical power here whatsoever. In order to do something like this, to link genes to risk-taking, we shouldn't have a sample of 100. We should have a sample of 100,000 or something. There's just nothing here. Even if you're trying to be Bayesian about this, I guess power is a bit weird if you're Bayesian, but there's just nothing you can learn from this type of study. So I published this. It's not retracted. There is no fraud. There is no error. I just don't believe in it. So it's hard to correct such results. At the end of the day, I think I fooled the world, but I also fooled myself, and I spent many years looking into this further, doing slightly larger studies, trying to replicate it, and it became, of course, harder and harder over time. But in some subset of the data, there was always something, which made me continue for a few years until I really realized this is just dead, forget about this. So we can all make mistakes, and I think that's fine, but we want to speed up this process and stop maybe wasting so many resources on noise. We can learn from failures, but here I really think we did not learn much. Okay, so maybe a more informative title than just replications and uncertainty could have been how there have been and still are replication problems and how results might not generalize, and how we can design studies and do pre-analysis plans and multiverse analysis and change incentives and explore heterogeneity and do team science and consider scientific workflow, etc., to improve the situation. I mean, there are many problems, and the problems are not going to look the same across all disciplines, across all types of research questions, data types, etc. So there is not one silver bullet, and I think it's good that we acknowledge this. I'm going to talk about experiments, but this is, of course, not just an experimental problem. I mean, the beauty of doing experiments, as I'm sure many of you know, is that we can actually replicate things. We can collect new data and test the same hypothesis and see to what extent do we get similar results. In large parts of economics and other social sciences, replication is not an option. We cannot get new data for the same phenomena. So then we need to think about other things, and I know that EJ will talk about some of these things later. But I'm going to focus on experiments. This is, of course, not just a social science problem. We know that there are many problems in medicine, biology, etc. But I'm going to focus on social sciences because I'm a social scientist. Okay, so which results replicate? We know that that's going to depend on many different things, like what's the original p-value, what was the original statistical power, what is the statistical power in the replication, to what extent were the original results sort of subject to researcher degrees of freedom. There are many ways you can get the statistically significant results. Some where you actively search for significance and ignore non-significant results. But as sort of, if you think about phishing as clearly the thing you shouldn't do, and that's clearly sort of intentionally bad, you can move to p-hacking and eventually to forking as in sort of the garden of forking paths, where you're doing an analysis sort of that is based on the data. You get to know the data. You are testing a hypothesis, but you haven't specified exactly how you will test it. So you let the data tell you how to test it. Eventually, at some point, something will be statistically significant. And it's very easy to convince yourself that sort of the chosen path was the one you were looking for all the time. So I think it's very easy to mislead yourself by doing this type of analysis. We know that publication bias matters. Even if none of us are engaging in phishing, p-hacking, or forking, if we're all testing the same hypothesis, by chance, some will find something statistically significant. If this is the only result that gets to be published, of course, the published literature will be misleading. So we know that all of these things matter and are trying to assess sort of how important are they. But something else that, of course, matters too are priors. So what's the probability that the hypothesis is true in the first place? I mean, many of us are doing frequently statistics, but we're still thinking about priors when designing studies, when reading papers, etc. Why don't we pay more attention to them? Maybe because they're typically subjective, or not necessarily, but often, and can be hard to access. So whose prior should I be thinking about when evaluating some results? And then I'm going to be arguing that perhaps we can get help from surveys and prediction and decision markets to get to priors for different types of hypotheses. And maybe we can use them moving forward when thinking about which studies do we actually want to run. So before talking about experiments, I just want to say that there's nothing specific about the experiments here. It looks like there are problems for many types of data, for many types of methods. So here's a very nice paper by Albert Brodeur and co-authors, where they basically look for evidence of p-hacking for different types of methods in economics journals. So when there are two peaks and a valley, something looks a bit weird. Like, what's the true distribution of p-values? That's unclear. But if you have sort of two peaks corresponding to some important thresholds for what you want to call statistical significance, then that's evidence of something going on. If I'm testing a hypothesis and I have a p-value of 0.11, what if I control for gender or interact gender with my treatment or something? Can I get it to be statistically significant? That would be one sort of explanation for why you would see these weird results. And there is evidence of sort of these two peaks and a valley for different types of economics literatures. And it looks like it's worse for papers using instrumental variables and differences and diff-in-diffs versus RCTs and regression discontinuity designs. But it looks like there are problems basically everywhere. Okay, but I'm going to not talk about those types of studies. I'm going to talk about replications, where we actually get new data to test the same hypothesis. So I'm mainly going to talk about direct replications, what some people call exact or precise replications. So here we try to use the same methods and materials as the original authors. We typically ask them, could you please share it? Or sometimes we get it from the journals. In a conceptual replication, we instead choose to vary something in the design of the study, something about the statistical testing. And the line can be a bit blurry, because sometimes you try to do a direct replication, but you don't get all the material from the original authors. And maybe you actually end up doing a conceptual one because there are sort of mistakes, or you just don't really know exactly what was done in the original study. We're going to say that something replicates when we find an effect that is in the same direction as the original study, and this is a statistically significant result. Many people really dislike this binary definition of replication success. Fair enough, but we also present a bunch of other replication criteria as well, and one that I will focus on as well is the relative effect size. So what is the replication's effect size compared to the original one? And these two tend to correlate highly when we have high power in the replications. So, I mean, for many of us, why did we start doing replications? I can't speak for everyone, of course, but I can speak from my personal experience. That was partly because of this candidate gene stuff that I really believed in and continued and wasted so much time and money and energy on, and it was just noise. I think for many in psychology, you can correct me if I'm wrong, what really triggered it was this Daryl Bem and co-authors paper in a top psychology journal in 2011, where they argued that extrasensory perception is real. A series of studies showed statistically significant results that extrasensory perception works. Another study around the same time was this power posing phenomena in 2010. Some of you may have heard it. So this is a study with 42 participants where they argued that if you sit or stand like this for a minute or two versus sit or stand like this for a minute or two, you get higher testosterone levels, lower cortisol levels, lower stress hormones. You become have increased financial risk-taking and increased feelings of power. So this has led to what is the third most viewed TED Talk, and it keeps increasing in number of views. And why is that problematic? Because when we try to replicate this, a few years later, we basically find nothing. And many other studies since then have failed to replicate it. And I think that specific example is sort of an example of success and failure. Success in the sense that many replications failed to replicate the result. These replications were eventually published. I'm guessing that nobody in academic psychology today believes in power posing, so the field has moved on, great. But the rest of the world continues loving power posing. If you take a leadership course, you will most likely power pose. So it's hard to correct these false positives once they exist out there in the literature. Okay, so one of the big landmark projects that started, I think, shed light on the replication crisis was this project led by Brian Nosek plus 270 co-authors. I'm sure many are here in the room. Where the idea was to try to replicate as many studies as possible from 3 top psychology journals, all published in 2008. At the end of the project deadline, 100 replications had been performed. Out of the 100 original results, 97 were positive. So you can see to the left here that something magical is happening at p less than 0.5. And then you can look at the 100 replications, and nothing magical is happening there. So about a third of the results clearly replicated. About a third clearly did not replicate, and for about a third it's a little bit more uncertain. So we were super inspired by this big psychology project and tried to do something more small scale for economics. There are some differences between experiments in economics and psychology. We typically don't do these experiments in our classes. We have to pay high show-up fees, so we just couldn't afford to do so many replications. So at the end of the project deadline, we did 18 replications. So we went through 2 top econ journals, all experimental papers testing a hypothesis, a specific time period, looking for main effects. There were not that many interaction effects, but if anything from the big psychology project, the studies that were the least likely to replicate were these interaction effects and triple interactions. We thought we had high power here in the sense that we have 90% power to detect 100% of the original effect size. That sounds good if we don't think that also true positive results tend to be inflated. So with this semi-high power, we find that 11 out of 18 results replicate. But in this project, as well as in many of the others, there are also some problems. Like in one of the studies that failed to replicate, things had changed. So in the original study, this is this Ifshar and Sargami study. In the original study, they used a video of Robin Williams, which was supposed to be the most fun clip there was in the world. And they wanted to induce emotions and then look at time preferences. So when we do the replication, Robin Williams has committed suicide. What do? Do we change the video? Then it's a conceptual replication by definition, or do we keep it? We kept it. People didn't find it so much fun. So I think that was a mistake on our side, and I think that for all of these projects, there are mistakes also by the original author, so I think we should acknowledge them. Okay, so after that project, we tried to do something related, but for now, social science experiments published in Nature and Science. So we went through these journals, looked for all experiments using subject pools that we could access, like humans, not non-human primates, no babies, etc. We went for 21 studies that we now aim to have substantially higher power in our replications. So we have a two-stage procedure where we in the first stage of data collection have 90% power to detect 75% of the original effect size. If the result does not replicate successfully, according to this binary statistical significance criterion, we do a second round of data collection so that we have 90% power to detect 50% of the original effect size. So we can see how much do we learn when increasing power this way. And at the end of the project, we find that 13 out of 21 results replicate successfully. Is the glass half full or glass half empty? I think you can choose. So to these projects, we added different types of markets to see sort of, can we get researchers to predict replication outcomes? And if they can we use this somehow moving forward? So prediction markets have been studied in economics and political science for a long time. They're typically used to study political outcomes, like who will become next US president, sometimes entertainment events, like which movie will win an Oscar, etc. So they basically function in the following way. You have a contract in whether Obama will become president in 2008. If he becomes president, the contract is worth $1. If he does not become president, it's worth $0. So we want to interpret the price of this type of contract as the probability that the market assigns the event. So the probability that Obama will become president. If you think the probability is higher, you should buy this contract. If you think it's lower, you should short sell it or buy the opponent's contract. So sort of why this could be a good way to aggregate information is that this is not about my political preferences, who do I want to win? This is about who do I think will win. And here I can incorporate information based on what my friends and family think, what I read in the newspaper, etc. So you don't necessarily need big representative samples of people who truthfully say who they will vote for. You just have people betting, sort of putting their money where their mouth is. So we're not interested in politics, we're interested in scientific outcomes. So we added prediction markets to a bunch of these replication projects and gave researchers money, $50 to $100 and said, now bet on the outcome of these hypotheses that are being replicated. These markets were open for typically 2 weeks, and we had between 30 and 200 participants, depending on the markets. So before participants come to these markets, we ask them in a pre-market survey, what probability do you assign this hypothesis replicating? And the markets have performed okay. I mean, not fantastic, but better than chance. And it's a little bit hard to say sort of like, yeah, what do we do with this? We learned something, I think, that there is something systematic about studies that replicate versus fail to replicate, and maybe we can use markets to some extent. So in the latest project on this, with several co-authors, including here in the room, we decided to not run a prediction market, but a decision market. So here we wanted to use these prices from the markets to decide which studies to replicate. So we went through PNAS, so the Proceedings of the National Academies of Sciences, USA, searched for all experimental papers testing a hypothesis in a between or within subject designs on a platform called Amazon Mechanical Turk, an online platform where you can run experiments. Nowadays, many people run experiments on Prolific. This was at the time when MTurk was the only game in town. We invite researchers, social scientists in psychology, economics, judgment and decision-making, etc., and say, here's $50, now bet on these 41 studies. But we're not going to replicate all 41 studies. We will for sure replicate the 12 studies that have the lowest prices in the markets, so the 12 studies that participants think are the least likely to replicate, the 12 studies with the highest prices, so the 12 studies that researchers think are the most likely to replicate, and 2 random studies. And we're scaling payoff so that everything is incentive compatible. So we have a high statistical power here in our replications and find that there's a fairly decent correlation between prices and replication outcomes. So we have an R of 0.5, and we find that 14 out of 26 results replicate. We also find that replication rates differ between the top 12 and the bottom 12. So it looks like the markets are pretty good, but again, far from imperfect in actually choosing what to replicate. So I think something we've learned from these projects are basically like, okay, many results do not replicate. How many? About the half. Are things getting better? Not so sure exactly here. I think in general things are getting better, but we can't really see much evidence of that here. We also see that for true positive results, original studies tend to have inflated true positive results, which of course also has consequences for meta-analysis that need to take this into account. There is also something systematic about results that fail to replicate, and the markets are picking something up, but not perfectly. Something like original p-values are relevant here, so they are good predictors of replication success in all of these projects. To what extent are the results here generalizable? Very unclear. I mean, these are all for specific time periods, specific sets of papers. What can we say about papers today? I would bet my money on them replicating to a higher extent, but I don't know what replication projects are being done right now. Okay, so all of this, and I'm sure many of you know it, and we will hear more about this from Naomi and others, are sort of, there's been a big now surge of the use of pre-analysis plans. So, and I think pre-analysis plans for the type of research that I do are great. So I'm a big fan. I think the beauty of them is that you can really sort of convincingly show what is confirmatory versus what is exploratory in your research. And I think they help you design better studies, think about the analysis ahead of time, and all of this. But if you take a step back there, I mean, it's not like they will solve all problems. And one reason is because sort of at the end of the day, if you think about all potential data analysis you can do as the garden of forking paths, the pre-analysis plan would show one path in this garden of forking paths with meaningful p-values. But if we were all to sit down and design a pre-analysis plan for the same study, we would probably have many different forks in this, or paths in this garden of forking paths. So different researchers might choose different forks or write different pre-analysis plans. Given this, we will underestimate the standard error in the statistical test. So then the question is this a real problem, or is this just a problem in theory? And there are different ways to think about this. So one would be to do this so-called multi-analyst approach that was sort of launched in this paper by Silbersan et al., where the idea was to look at what is the natural variation in analysis and results in a given data set. So what happens when you give the same data, same research questions to different researcher? How much variation do you get in results? The other way would be to say, okay, what's the theoretically justified set of analysis and results in a given data set? And this can be explored with multiverse analysis or vibration of effects or specification curve analysis, different names for basically the same type of analysis, which is also interesting as from like an anthropology of science perspective, that articles about this showed up in different types of fields around the same time, trying to solve similar problems. So there are many such projects, and I just want to highlight one, which was led by Albert Menkveld, where the idea was to look at sort of uncertainty from analytical heterogeneity in a multi-analyst study. So here, really big data was given to a bunch of different research teams in finance. They were asked to test the same 6 hypotheses, write a short paper, a short report, where they outline their choices and their results. These reports were then reviewed by senior researchers in finance so that the researchers could get feedback on the analysis that they had done and potentially update it. And there were several such sort of review elements, several stages. And at the end of the day, there's just this massive variation in what researchers find using the same data, same hypothesis, and this is by good researchers who are doing very good analysis, yet there is this dramatic variation. And sort of taking a step back, what I think we need to focus more on is like, okay, given this variation, there is something that is closer to the truth. How do we select it given this, all of this variation? And what does this do to the standard error here? Well, we underestimate it. So final thing before I end. So now we've talked about replication problems and semi-solutions. Pre-analysis plans, I think, are helping us, but they're not the end. We need to do other things too. Analytical uncertainty will also add uncertainty to any results we have, and I think that is well illustrated for non-experimental data. Another type of uncertainty, which we should maybe also consider, is design heterogeneity. What happens in situations where you ask different researchers to test the same hypothesis, they can design experiments, we will then implement the experiments with the same sort of population, and we will keep the analysis constant. How much variation is there in results depending on design heterogeneity? So we set up such a project for the broad question, does competition affect moral behavior? If you're in psychology or sociology or economics, you can have different ideologies that you can design experiments to basically show one thing or the other. I mean, you can think about competition in many different ways. Are we talking about markets? Are we talking about tournament incentives? Moral behavior? Do we mean trust? Do we mean fair prices? Do we mean cheating, charitable giving? You can illustrate this in many different ways. So we set up a project and we invited researchers in economics and psychology to design studies where we are paying for the data collection, where you have a control group and a treatment group with 200 participants in each. Should have monetary incentives, etc. And then we ran this with more than 18,000 participants. So what do we find? I mean, at the end of the day, we find a small but negative effect of competition on moral behavior. That's not really that interesting because this is very specific to our specific designs. But I think what's more interesting here is that there is substantial design heterogeneity. And it's 1.6 times as large as average standard error of effect size estimates. So again, there is this extra uncertainty in estimates that we need to do something about. And I think we can skip all of this. Final 30 seconds. Generalizability based on single designs or analysis can be limited. I think we need to do more team science. And I know there are big proponents here in the room of this. And we need to think about what we're going to do with our incentive system. Most of us are not really going to be rewarded for having 200 co-authors on a paper. But I think we can learn quite a lot from such projects. So how do we set this up correctly? We need to think about what we're doing with standard errors and confidence intervals. I love registered reports as a way to publish papers. This is basically where you submit a pre-analysis plan ahead of time and saying why the research you do, why it's interesting to test these hypotheses, etc. It gets peer-reviewed before there are any results. Then we really focus on sort of, is this interesting? Is the design good? Does it make sense, etc.? Obviously, this can work for experiments, but for large chunks of empirical social sciences, this is not really an option. So what do we do instead? And also thinking about things like fairness. I mean, many people can afford to pilot and then register something. And that can be extremely problematic. But we can save that for later. And I think I have tons of collaborators on all of this, so we can end with that slide. Thank you very much.
Well, thank you. Thank you very much for this brilliant session. And we now continue with Eric-Jan Wagenmakers from the University of Amsterdam.
Good afternoon, everybody. So my talk is about hidden uncertainty and how to reveal it with robustness reports. Oh, there we go. So first I'll talk a little bit about bias in academia. Then I'll discuss hidden uncertainty in data analysis. And then we're going to turn to two possible solutions: synchronous robustness reports and the journal of robustness reports. Where? Whoa. Okay. I think this is the slide that I'm supposed to talk about. So suppose Dr. X has a favorite model that she has worked on and published about previously. She designs an experiment to test a prediction from... I'm not touching this at all. Okay, so she designs an experiment to test a prediction from her model. She collects the data. This takes a lot of time and energy and money, perhaps, and part of her career and those of her students ride on the outcome. One click. Now the data need to be analyzed. If the model fits the data, the experiment is a success. If the model does not fit the data, it is deemed a failure, and it casts doubt on the earlier work. The question is, who is, without a shadow of a doubt, the most biased analyst in the entire galaxy, past, present, and future? Of course, it is X. So basically, when we analyze our own data as researchers, we have a lot of hopes riding on the outcome. And what this means is that we can easily fall prey to a whole series of biases. If you look it up online, you will find a list of about 166 different biases that we can fall prey to as humans. I want to highlight two of them. Confirmation bias. Here's a quotation by Francis Bacon. The human understanding, when it has once adopted an opinion, either as being the received opinion or as being agreeable to itself, draws all things else to support and agree with it. And another one, my favorite bias, is the bias blind spot. And that is the belief that you are less susceptible to bias than most other people. And I don't know whether this has been researched, but I believe this actually also happens on the group level. You may argue, well, they may succumb to bias, the out-group, but we, the in-group, for instance, ecologists, physicists, mathematical psychologists, economists, medical doctors, are somehow immune to it. It's other people's problem. Okay, so this bias is obviously a problem, and it kind of partly causes the issue of hidden uncertainty in data analysis. So there's two kinds that I want to highlight here. The first kind of hidden uncertainty is where the researcher tests many different models and then reports only the one that gives the desired result. So you can call that cherry picking. And the problem with cherry picking is we do not see all the cherries that didn't look so good, right? We only see the sparkly, nice cherry. So, and this can be caused by those biases that we all fall prey to. And the second kind of uncertainty is where you test and report only a single model. So we could call that model myopia, in Dutch bijziendheid. So, for instance, if you're an expert on a particular kind of modeling, that might be the kind of modeling that you apply exclusively, and you're kind of unaware of what would happen if you would apply different analysis strategies. And when we read articles in academia, usually you will see a single analysis conducted by a single data analyst. We don't know what would have happened to the conclusions if we had taken other choices with respect to data preprocessing. We don't know what would have happened if we would have used different models. And we don't know what would have happened if different people would have analyzed the same data. And I've been studying these issues together with Balázs Axel from Budapest and Alexandra Sarafoglu, who is sitting in the audience. And one of the papers we wrote about this problem is here. One statistical analysis must not rule them all. And you see here the image of the iceberg. That's our favorite metaphor for the problem. Here's the one that we had drawn up ourselves by Victor Beekman. And there's two aspects here. So you see these people on the boat. They're statisticians discussing some detail, but these statisticians are kind of overlooking the bigger picture here, right? And so what is the problem? the problem is really twofold. You only see the tip of the uncertainty iceberg. So underneath the waterline, there's all the conclusions that could have resulted had other people analyzed the data, had you done a different analysis. What you do see is the part of the iceberg that's above the waterline, and not only is that just a small part, it's also the part that looks best, right? And that's because when people analyze their own data from their own experiments, they usually, they care about the end result. For instance, I'm going to give you an example from neuroscience. Let's say you do an experiment in fMRI, you measure brain activity, the experiment costs 20,000 euros, you analyze the data, and you plot a picture, and when you plot such a picture of the brain, you will see a color-coded activation, right? So you do your analysis, and you see there's no activation at all. It's just if you compare two different conditions in your experiment, right? So nothing has happened. There is, I don't know whether you have looked at this literature, but I have not come across a picture that just shows an empty situation like that with no activation whatsoever, right? Why doesn't this work? Well, let's say you're the PhD student and you present these results at lab meeting and you said, well, I did the experiment, nothing works, right? Then that's never the end of the story, right? Your lab members and your advisor will helpfully suggest other ways to analyze the data, right? And at some point, after a lot of trying, you will find some activation somewhere, and there will be a story somewhere that connects that activation to a particular theory. And this is what's being published. Okay, so one way to sort of invert that iceberg and actually see what's underneath the waterline is to have different analysts look at the very same data, right? As Anna already discussed. And a wonderful example of this is the cuneiform competition. So I want to walk you through this. So this is one of the first many analyst problems, and it's a many analyst problem from 1857. So this is cuneiform, in Dutch spijkerschrift. So this was a way of writing that was used in Mesopotamia for over 3,000 years. At some point, people stopped using it, and at some point, people stopped being able to read it. So at some point, they found all these tablets with these inscriptions, and they wanted to decode it. So initially, this is a difficult task, right? And so luckily, there were a number of inscriptions, such as the Behistun inscription, right, on the inscribed in the mountain here. And the nice thing about that inscription, it's like the Rosetta Stone, where you had 3 different languages. So people couldn't read neither of them, but it was still very helpful. And the interesting part about this inscription is that it's also nice that it still survives, because in, I don't know whether it was the First or the Second World War, but since it's so nicely carved out in the mountain, it was used for target practice at some point. But I guess they missed, and that's why we still have it. Okay, so there was a discussion at some point when they just started to understand the cuneiform language. Do the experts who claim to be able to read those tablets, do they actually know what they're talking about? Or are they making it up? Are they fooling themselves? So what was done in 1857 is that the same cuneiform text that neither expert had seen before was sent to 4 experts. Each expert translated the text independently and sent their translation in a sealed envelope to the British Royal Asiatic Society. So it was ceremoniously opened at a meeting, and the similarities in translation were striking. They were so striking that it dispelled any doubt about the experts being able to decode the language, decipher the language. This is another much more recent example of a many analyst project. This was when, way back when we had a corona pandemic, the UK government was interested to know the number R, the reproduction number R. You will remember this: when R is 1, you on average infect 1 other person. If it's larger than 1, say 2, you infect on average 2 other people. So if it's higher than 1, the disease is spreading. If it's lower than 1, the disease is retreating. So the UK government had a lot of data. And what they could have done is they could have just given it to one analysis team and then gotten their results. But they did something that was much smarter. They gave it to 9 different teams who then analyzed the data independently. And here you see the outcomes. And one thing that you note is there is a certain consensus overall when you look at all 9 together, but there's also some stark differences. And in particular, any specific team appears to be more certain than what you get when you look at all of it. Right? So this was highly informative and a really good idea. This is another example. This is another example. So here, this is again neuroscience, where fMRI data were shared with many different teams. I think, well, we'll see that later. I think it was something like 70 different teams. And you see that means this is a many analyst project, right? So you get many different authors. And 70 different teams. And they were given 9 hypotheses. And then they had to assess whether that hypothesis was supported by the data or not. So these are the 9 different hypotheses. You see them here. And it doesn't really matter what the hypotheses are specifically. What matters is the fraction of teams that report a significant result. So ideally, we want this fraction to be either 0 or 1, right? Because that means that the teams agree. What we do not want is fractions that are somewhere in between, right? And so we do see that for 5 of those 9 hypotheses, there is substantial uncertainty between the teams on whether or not that particular hypothesis is supported. You see the fraction of teams reporting a significant result. It's almost 0.40, 0.20, 0.30, right? What that means is that had you given the same data set with the same hypothesis to one team, they would have said, yes, that hypothesis is supported. Had you given it to a different team, they would have said, no, it's not supported. Right? And ideally, this is not what we want. But I guess the main point is, this is really important to know, right? Because otherwise, you will think, there's really good support for it not being there or for it being there, and then that's just merely a result of looking at the tip of the iceberg, because what's underneath the waterline shows you something different. So these multi-analyst efforts can provide crucial insight about the fragility or the robustness of the conclusions. But the drawback is that the amount of logistical effort involved makes routine application infeasible. I've been a part of some of these multi-analyst efforts, and it takes years from your life, and you cannot do that just for anything. You could, of course, say, well, let's only do it if it's really important, but there's too many things that are really important, so it's still highly problematic. So one of the things we've been thinking about is how can we make this process more efficient? And this is where the synchronous robustness reports come in. I think synchronous robustness reports are a fantastic idea, but so far, no editor of a journal appears to agree with me, and this is why we have founded our own journal, a Diamond Open Access journal, the Journal of Robustness Reports. So that's kind of the backstory here. Okay, so the main idea of the synchronous robustness report is to make it easy to publish several analyst reports. So the process is really simple. Let's take a really important study. You wouldn't do it for anything, but let's take a study that is potentially really important. For instance, one that I saw recently, I think it was published in Nature, was on the possible effect of lithium on the prevention of Alzheimer's. very important study. People are really excited about it. But what you see is you just see the data and you see one analysis and that's it. Right? So wouldn't it be great if we could invite, let's say, 2 different analysis teams and just say, reanalyze the same data, test the same hypothesis, and then write a short comment, say 500 words, in which you detail your conclusions. So it seemed to me that it was relatively straightforward. And Nature Human Behavior agreed in the sense that they liked it, and they liked it enough to publish it. Here's the paper, Introducing Synchronous Robustness Report. And then, of course, the immediate next step was to ask some editors, will you implement this format? Right? And it's for editors, it should be really simple because everything is under editorial control. You can pick the article that you think this is really a really good one to undergo such a methodological commentary with these robustness reports. And then you could also say how many you want. Right? And so everything is completely under your control. And you could also say, I only want them 500 words long. Right? So it's not really a big investment at all. And I talked to several editors, and they appear to be very hesitant. It's really funny. They think it's a good idea, but they don't want to do it. So then we thought, okay, how should we solve this? Well, we felt maybe we should just demonstrate that it's a feasible idea. And also, I secretly thought, well, if, say, PNAS doesn't want to do this, maybe in the Journal of Robustness Reports, we can do robustness reports for a lot of articles from PNAS, and at some point they will be sufficiently irritated that they will do this themselves. Okay, so before I talk about the Journal of Robustness Reports, there's a short commercial break. So I never want to let go of the opportunity to attend you to JASP, which is the free and open source software package for statistical analyses that we have created. So if you're still using SPSS or Minitab, ditch it and shift to JASP. And more information is on jaspstats.org. Usually, I also give a whole presentation about why everybody should be Bayesian, but instead, I just want to attend you to this children's book that I wrote, Bayesian Thinking for Toddlers. I actually brought it along. I have 2 copies of Bayesian Thinking for Toddlers, and I have 2 copies of the Dutch version, Bayesiaans Denken voor Peuters. So I have 4 copies. So if you want one, when we're done here, you can walk up to me and first come, first serve. I think it's reasonable that people who have children or grandchildren, that they have first dibs on the books, right? So this is actually by far my most popular work, which is... Okay. So back to the Journal of Robustness Reports. So we founded this journal this year together with Balázs, Axel, and Alexandra Sarafoglu, whom I have already mentioned, but also with Susanne Hogeveen, who's also in the audience, František Bartos, and Chris Chambers. So this is what the website looks like. So I'm showing this to you as well because it is actually part of the Sci-Hub universe of journals. So this started in physics. It's an initiative to promote diamond open access publishing. So this means, for those of you who don't know this means that you can actually publish your article without having to pay for it, which is, strangely enough, how the system has evolved, that we have to pay for our articles for other people to read them. But at the Journal of Robustness Reports, we do this very differently. There's also, there's also some guidelines. There's an editorial here on what we expect those submissions to our journal to look like. And there are strict rules, and the strictest rule is about the word count. So it's 500 words and 1 display element. And this is, of course, extremely restrictive, and people who talk to me about it this is their main point of critique, like, why would you restrict this? Well, the reason why we do this is we want to convince Nature, Science, PNAS, etc., that it's really easy to do this and that they don't need to sort of spend a lot of journal space on it. It can be really efficient. Of course, if you have a much longer paper, you just basically summarize it in 500 words and you just link to a more extensive paper online. So, as part of this editorial, we also had a concrete example. So the example was based on a data set that we collected at Christmas drinks of our department, where we tested the hypothesis whether or not people would prefer the taste of Belgian mineral water, Chaudfontaine, to Amsterdam tap water. If you look in the literature, you will find that in general people cannot discriminate tap water from mineral water. And of course there's some, I guess, lessons here. Not only is mineral water about 1,000 times more expensive, there's also, of course, the plastic bottles and the whole production process and everything is more taxing to the environment. So I went in there with some confidence that people couldn't taste the difference, also because I couldn't taste the difference myself. But my wife actually could taste the difference, so I wasn't 100% sure. So these are the data. So you see that there are actually some. So you got 2 cups of water, one with Chaudfontaine and one with tap water, and you had to indicate how much you liked either cup and which one did you think had the Chaudfontaine. And so you see, for instance, that there are a group of people who basically say, I cannot taste the difference, this is just water, right? And those are the people who, oops, that was definitely my bad. Here, this is the one. Those are the people over here, that's this vertical line. But if you squint, maybe there's slightly more people who prefer Chaudfontaine over tap water. So if you do a Bayesian analysis, it just says absence of evidence. That's the analysis I believe in. But if you do a classical analysis and you calculate a p-value, so we collected all the data, we calculate the p-value, and it comes out as 0.049. So, so that's why we titled the paper like, oh, people can absolutely taste the difference. And then that was just the target article. And then there were 2 robustness reports. Just as an example, one by Alexandra, preference for Chaudfontaine or bias towards the preferred option. And there's also, with our robustness report, a 1-sentence abstract. Although participants' taste scores were influenced by their preferences, they still generally favored Chaudfontaine over tap water, which confirmed the original claim. Okay. Then there was this is the only display element that was allowed, and in the interest of time, I'm not going to go over the details, but you can appreciate the aesthetics. And then the second one was from Susanne Hoogveen, Water Tasting, a Bayesian Multiverse Analysis, where the abstract reads, varying data, inclusion criteria, and prior settings, a Bayesian multiverse analysis failed to provide robust evidence for the claim that people prefer Chaudfontaine over tap water. And then this is the display element that Susanne created. And again, I don't want to go into the details. I just want you to appreciate the aesthetics. And so what have we learned? Well, actually, this was an extremely simple experiment. And still, I personally learned a lot from both of these reports. I think they really add value to what was originally reported. And I think we learned here that we are still unsure. And if we want to know with more certainty whether people prefer Chaudfontaine over tap water, we need to do this again with a much larger sample. So this is similar actually to what Anna already suggested for her genetic study, but I'm sure it was more expensive than this one.
What was your number in this research?
number? Sorry. Oh, N. Was it about 100? 92. 92. Okay, so this is my concluding slide. So bias and model myopia are distorting the scientific record and they hide uncertainty. That hidden uncertainty can be revealed by multi-analyst efforts and robustness reports. And the Journal of Robustness Reports is one initiative to encourage a broader uptake of several analyst projects. And if you see this and you like it, please consider it. Contact us for a submission. You may even like the initiative so much that you are interested in being on our editorial college. If so, please send us an email. Thank you very much.
Daar gaat mijn microfoon. Dankjewel. Thank you, Eric-Jan. The final speaker in this first session is Naomi Ellemers from Utrecht University.
Even een glasje water. Where's the thing? Yeah, so debating the facts. And I'm a psychologist, so I'm going to take a slightly different perspective to the topic that we're debating today. Talk about also the psychology of doing research. And so it's important also to have the context of what we're talking about. And these are conclusions that have been drawn in the literature. Dismissing, I think, a lot of the research, dismissing particular branches of science. And this is one way to think about these issues, to say, okay, there's a lot of wrong facts, you cannot trust published research, and so what can you do? And so this is the context, I think, against which I also want to consider these issues. No, this is not working. Oh, sorry, wait a minute. Yeah. So what I want to talk about are four different issues. I want to talk a little bit about what social psychology is about. That's my area of science. I know most about it. Then I will talk a little bit about how we can examine the issues of interest in my discipline, at least. I want to ask the question whether there's one best way of doing that. And finally, I want to discuss some thoughts about why this might be important. So what is social psychology actually about? In my view, it's about prediction of human behavior in social contexts. And what does that mean? Well, for instance, we do a lot of research with regulators. So this is a study we do together with the Financial Market Authority. And they are very much concerned about people in the financial service sector displaying unethical behavior. And there are different types of unethical behavior that you can display. You can be unethical towards customers, so you can sell products that are irresponsible and not in the best interest of these customers. You can also be unethical within your own organization, so perhaps not truthfully reporting your own performance or not acknowledging the work of your co-workers or whatever. And so one way to approach this as a regulator is to say, okay, who are these people? Can we predict who these are? How large is this problem? Who are these rotten apples? They are lacking a moral compass. There's something wrong with these people, and we need to identify them and punish them or remove them from these organizations. You can also ask a different question, and this is the question that we ask is, okay, where does this behavior come from? And so we thought, okay, perhaps it has also to do with how the work is organized. What is the climate in the organization? If there's a lot of emphasis on earning a lot of money or selling a lot of products, and it's less important on how you treat customers, that might be an important factor that predicts this type of behavior. And actually, that was an observation that we found. And then if you go one step further to say, okay, but how can you influence that? We thought that was very closely related to how the board of the organization approached these issues and the message that they implicitly sent into the organization, for instance, by accepting their own pay much higher than employees in the organizations without a clear justification for that. So one thing would be to say, okay, if you want to give a point estimate of the number of people who are displaying this unethical behavior, or if you want to get accurate prediction of who these people are going to be, that's one problem. If you want to understand what happens in the organization, how do behaviors in the boardroom impact on the atmosphere in the company, and how does that impact the behavior of individual workers, that's a completely different question. The second question is the one that is key to my area of research, social and organizational psychology. And so if you look at the theories in my field of science, the predictions that we have cannot always be classified as hypotheses in the traditional way. So we are not investigating laws of nature like gravitation. It's the same whether you're in Australia or whether you're in Holland. When you drop something, it will fall to the floor, right? Psychology is not like that. And so this is actually what we examine, is how the behavior of individuals differs across different contexts and different situations. And we know it's not just what people do, it's also about what they think about what they do, how they feel about what they've done in the past, how other people think about that, and that it is a whole self-reflective process. And we also observe that in the studies that we do. So research participants coming into the lab might already have read something about the phenomenon we're trying to investigate. They might think, oh, I want to cooperate with the researcher because I really want to be a good participant. Or they might want to say, oh, I want to show that I'm autonomous. I'm not going to respond to all the manipulations that I'm going to get today. And so people are not just passive objects of study, they are actively involved in the research that we do. And we know about these basic principles. We know that people think and act and behave in different ways. We know they compare to each other, how they relate to each other. This is what we investigate. We investigate how groups of people or imaginary a presence of group norms in people's minds can impact on individual behaviors, but not always, depending on whether these norms are activated in a particular situation, yes or no. We also know that people might behave differently, the same individuals, depending on whether they see themselves as members of a particular group in a particular context. So today I might think of myself as a psychologist, which is different to a statistician, but tomorrow I might think of all of us as scientists, and we're all in the same group, and we're different from people who are not being scientists. So the same individuals can think and act and respond differently depending on which group is salient in their mind. And these general basic principles, these are the types of theories that we try to examine. And what we're doing is not testing hypotheses, whether this is right or wrong. What we're trying to examine is, what does this mean in particular situations? How does this influence behavior in the workplace? How does this influence the way we researchers are also human, are doing research. And this is what we're trying to investigate. Now, in my own area of science, one of the topics that I'm very interested in is the psychology of morality. And if you look at all the theory that is on this topic, there's a lot of consensus that moral behavior relates to the way people reason about what is right and wrong, also relates to their judgments of what others do, also relates to the emotions they experience, guilt or shame about something that they did wrong in the past, also relates to their self-use, and it's all relevant, it's all connected to people's moral behavior. So this is the theory, but when you look at the research, and we did a review of all the studies that we could find there, we see there's a very large emphasis on just one part of this whole puzzle. So there's a lot of research studying how people respond in hypothetical situations to moral dilemmas, how they reason about this in their own minds. But we know much less on how they interact with each other, how they feel about that, what they actually do in practice, and how that impacts on their self-use. While the theory maintains that these are all important things to investigate. So the research very much focuses on one part of the whole puzzle. And I think this is a problem because to really understand the issues that we want to understand, we need to close the whole cycle of evidence. So we don't just need the theory and experimental evidence, but we also need to see, okay, how does this work in practice? And can we make changes, for instance, in these financial service organizations where this unethical behavior is a problem? And how can we resolve these issues? And will the experiments in the lab or repeating them in the lab or getting very highly reliable statistical results in the lab and working very much on that, will that help us get better results in this organization? And to be able to do that, I think very much we have to do all these different types of research. And so it's important to think about if this is the study of human behavior and emotions and interpersonal relations and group mechanisms and intergroup relations, how can we examine this? And one of the things that we did also related to the COVID pandemic was after the pandemic, we collected with a group of colleagues a lot of evidence on what was studied in terms of recommendations based on science and how these influenced the policies that were implemented. And we wanted to find out whether these studies revealed that the recommendations had been consistent with the results that were obtained. And by and large, they were. So the results turned out to be confirming the recommendations that had been made on the basis of previous evidence. But what we also see is a very unbalanced representation. So there was a lot of empirical research was done, but not in the real world. We don't know very much about how this works in the real world. We don't know much about robustness across different types of populations, and we don't know much about broad application of these insights. So what we get a lot with this type of doing research is that we can see, okay, apparently in this case, the recommendations based on prior research were reliable in the sense that they were substantiated by research done during the pandemic, but it was very one-sided type of data. And so some of my colleagues have also been investigating, for instance, what is the impact of recommendations that were made at some point that the big problem is the statistical power. So you need much bigger sample sizes in psychology to get robust statistics effects. And so here they investigated different journals, different points in time, and indeed they found that by and large, more studies included in a single publication, and there were higher numbers of participants in a particular study. So that's a call for having larger sample sizes and more statistical power that apparently was successful. But they also coded how these data were collected. And what we see here is that as a trade-off, perhaps, in order to get these higher numbers, more researchers were relying on online data collection and on self-reports only. Now, again, that is a legitimate way of doing research, but if you want to find out how does this work out in the real world, what will people do outside the lab, how is it going to work in organizations, then the over-reliance on these high-powered studies with online people just self-reporting on what they might do in hypothetical situations, but we don't really know what's going to happen in the real world, it's going to help us a bit, but it's not going to solve all our questions. What we also know from all this research on group effects and intergroup relations is that researchers and participants are also humans who interact with each other, but this is also something that has been found in animal studies, where you find that the behavior that is observed depends on the identity of the individual observed and the experimenter. So, for instance, even in animal studies, you get different results depending on whether there's a male or female experimenter doing the measures. And this is also true in some of the studies with humans. And so you are aware that these in-group out-group dynamics can play a role. We are aware that implicit bias or stereotypes can play a role. We are aware that social tuning effects might play a role. And there are studies documenting how this impacts on recruitment. It's easier to perhaps to recruit somebody who is the same group as you are, or on consent, on participating in a study. We know it impacts on stress responses that we see in the body. on reporting pain, on being able to persist in a task. We know that it impacts on data coding. So, for instance, coding facial emotion expression, it depends on who is coding that. Recognition of different faces, it depends on who is coding that. So there's a lot of evidence that the experiment participant effects are important and can influence results. So what you want to know, and this is of course something that has also been observed by people who are writing about weird samples. So we rely a lot on samples of Western, educated, industrialized, rich, democratic countries, and we should also include wild samples, so more worldwide, in situ, local, and diverse samples. But in order to be able to make this judgment, you have to start by registering who are your participants, who are your experimenters, your research staff. Now, if you go to the first large replication effort, the 2015 that was published, we went back to these data and we wanted simply to see, was there a record of the gender and the ethnicity of the research participants? And only if you know whether men or women, then you know, or you can even check whether that makes a difference in the replication. So it was not really recorded. So in half of the cases, the gender was not reported, and in more than 3/4 of the cases, the ethnicity wasn't reported. And to have this experimenter-participant interactions, you also need to know who were the experimenters, who were the people who were collecting the data, who were coding the data. And they're even less likely to have even a record of their demographics, so let alone that you can do statistical analysis of how this makes a difference. So this is a big problem, I think, ignoring these effects and not even registering the data that you need to be able to check for that. Going to another point, the point of pre-registration that was also mentioned here before. Some people think that is a mark of quality. Now, last week I was in an international conference and almost all the speakers said, well, I pre-registered all my studies as a mark of quality. And I think that's misguided, and I'm not alone in thinking that. And so here's data also collected on comparing studies that were pre-registered with a control group of studies that were not pre-registered. And if you compare these two groups, then you see that the pre-registered studies are typically published in higher impact factor journals, get higher altmetric attention scores, get more citations, include more statistical power analyses, and report larger sample sizes. So apparently this looks good, right? But what they also found is that it doesn't solve all the problems. So it doesn't imply that there's increased trust of people who read these studies in the outcomes. It doesn't mean that the positive results are less likely to be reported. It doesn't mean that there are larger effect sizes typically. There was no decrease obtained in statistical errors that was observed, and there was also no difference observed between the control group and the pre-registered studies in absence of deviations from the plan. And that's fine, because the people who think about this, they say it is fine to deviate from your plan if you are transparent about it, if you have good reasons for it. But the pre-registration solves some of the problems but doesn't solve all the problems. So it shouldn't be taken as a badge of quality. And so I think in a more nuanced way, perhaps it's not so useful to think about this is right and this is wrong, but perhaps to think, okay, perhaps the things that we're trying to establish are much more complex than we think. It's not very simple hypothesis like testing whether something falls here and just as it does in Australia. And I think that the non-replication incidents can also inform us perhaps about relevant boundary conditions of particular effects, and could be things that not everybody thinks of, like the gender of the experimenter, which wouldn't be a thing that everybody might be attentive to. And so this raises the question of whether there's one best way to do this. And this, of course, young scholars and students always ask us, what is the one best way to do the study? And I'm not sure that there is one best way. And it's also because there are different things that we might want to look out for. And so here's an example of a calculation that was made, that if you have a small effect, there's a downward trend in youth problems, in social cohesion. Things are getting worse in the world in general. This was a study done in Australia. And so here they just estimated if you have a 5% correction of this trend, seems like a very small effect if you look at the particular study at a particular point in time. But they argue that in the real world, if you have this cumulative effect of changing the trend a little bit, a few percent, then on the long run, you will have a large cumulative effect. So again, the effect size in one single study might be very small, but the actual impact of changing a policy slightly in the real world, the long-term effect might be much larger. And so what is important is, I guess, to think about different types of validity concerns that we might have. So we have been talking today a lot about statistical conclusion validity, right? And this is the question, is there a statistical relation between the variables that you observe in your study? But you can also ask, well, what about the internal validity? Is it a causal relation? Is this really the cause and is this really the effect? Or is it a correlation? Or is it a reverse causation? Or is it a spurious effect? Or is it something else going on? That's a different question. You can also have questions about construct validity. So perhaps you cannot replicate a study because your operationalization wasn't the best operationalization. So perhaps you can repeat the same procedure, but are you really examining the thing that you're interested in? And of course, the external validity. Can you generalize the results? And all these types of validity are important. And especially if you want to do science for policy or science for the real world, you have to find out about all these forms of validity before you know what you're doing. And optimizing one of them doesn't necessarily optimize the other one, and sometimes there's a trade-off. So you cannot say, I'm doing the best study that optimizes all these forms of validity. You have to do different studies in a larger program of research to optimize each of them in turn. But when you look at all the publications on replicability of results, you see that there's a large emphasis of all these publications on the statistical conclusions validity. We have a lot of insights, a lot of minds thinking about how can we improve the statistics, but we have less people publishing and thinking about how can we improve the internal validity, how can we improve the the construct validity, how can we improve the external validity, and these are just as important questions to consider. And so giving an example, again, from our own lab, is a study that we did many years ago in, again, a financial service organization where they were concerned about work-life experiences, and the whole literature at that point in time was all about work-family conflict. So your time is limited, your energy is limited, your workplace behavior is not compatible with your behavior at home, you're distracted. When you're at home, you're thinking of work. When you're at work, you're thinking of home. You cannot do your job properly. And so this organization said we have all kinds of provisions to help people to manage this work-family conflict, and we want you to examine which of these policies of our organization is the most successful one of helping people to compare this or to combine this. And so the first thing we did, we started talking to people working there. And we said, okay, so can you tell us about your work-life conflict and what is the organizational policy that was most helpful for you in managing this? And then they said, no, I don't experience any work-life conflict. I think it's just great, it's helpful. Since I had a baby, I'm much more efficient. I get much more work done in the same time. Or they said, well, when I come home from work and my baby is there, I really feel charged and I really am ready to go. And the same when I go into the house and I'm really, I had my intellectual stimulation and I'm really ready for the family again. Or they said, well, you can learn a lot, actually. Did you know that I learned to negotiate for my kids? And that's very helpful because I can also use it in the workplace. So I'm much better at work now because I learned to negotiate for my kids. Or they said, well, it gets you different perspective. You come home from work and you feel very frustrated, and then you come home and with your children and you're happy and you think, I don't care about work anymore. So they were not talking about work-family conflict. They were only talking about how they were benefiting both in the family and in the workplace from having these two things. So this was the whole literature was about work-family conflict, and the first thing that people tell us is, no, that's not what we experience. So we had to make a change of plan, and we did. And so we had a large project where we had the interviews, we had questionnaires, we did experiments, we had observations on the work floor. We were able to get objective indicators of health, people's fitness, people's body mass index. We got productivity records. We could do this longitudinal research over time to see how it was changing. And we had a lot of people participating in the study doing 4 years of research. And what we found actually is that these organizational arrangements didn't matter. Because what mattered was what your team leader said. When they said, well, yeah, we know that there's this option to go part-time, but if you use that, you forget about promotion in my team. So that was a no-no. Or the team leader would say, yeah, I know it's difficult to do this, but hey, you know, I'm going to make this work for you because I think you're very important for this team and I want to keep you on board. And that makes the difference, not the provisions that were there, but whether your team leader would encourage you to do this, or whether your team leader would only see problems. And then we found people were happier, were healthier, were more productive, and we developed new theory about a work-life facilitation as a counterpoint to work-life conflict. And so this is how we do research. It's not about testing hypotheses for right or wrong, but trying to find out what's going on in the real world and how does it work, and what is the moderator, what is the thing that we might change to make this better. And using all these different methodologies and using all these different approaches and different forms of data collection, we think it's much more informative, if this is your goal, than repeating the same study in the lab to see whether you can replicate it. So why is this important? I think it is important because we are humans too, as researchers, right? And so all the psychology that we do research on also applies to how we do research, how we talk to each other about doing research. And we have feelings too. We are not just rational thinkers, we are not just processing information, and so we are also influenced, for instance, by institutional mechanisms. So the competitive incentive systems were already mentioned before. What do we reward people for? What do we promote people for? What do we expect researchers to show us in the beginning of their careers? What do we publish? And it's not the journals and the editors and the reviewers, that's us collectively, right? We are the ones who collectively decide, oh, we're not going to publish this because it confirms a hypothesis that we already know, or we're not going to publish this because it's an unexpected result, it goes against the theory. That's us deciding what gets out there, and so we have an influence there. And it's not just within disciplines, it's also between disciplines, that it's easy to say, oh, my discipline is doing better than your discipline, but that's not necessarily helping science. We also have these group-level mechanisms, where we see that the disciplinary approaches have very different methodologies, but also that evidence is intertwined with identities. So if you criticize a particular way of doing research, or if you criticize a particular way in which people are being educated, you have to be mindful that people's identities are intertwined with that. And so you can say, oh, they should just, you know, acknowledge that they have been wrong for 20 years, but these are people with emotions, and if you want them to change instead of getting defensive, perhaps you also have to think of the psychology of how do you get people to change, and that might require something different than just hitting them over the head and telling them every time that they are being wrong. And I think also in my connection with the young scholars and with the students who are being trained, there's a lot of stress and uncertainty coming from this focus on there's one right way of doing research and everything else is wrong, or if you make a mistake, then you must be a fraudster. And so people are very afraid to explore data, people are very afraid to engage with unexpected results. People are very afraid to engage in creative thinking if something doesn't come out the way that they predicted. What else might it mean, and how you can investigate that in another study? And I think this is the type of thinking that we need in order to advance science, and it's being discouraged by this focus on being right or wrong, of if I'm right, you must be wrong, or you must have cheated. And so I'm a strong believer in the founding father of my discipline, Kurt Lewin, who said there's nothing so practical as a good theory. And he talks about how behavior is a function of the person and the environment. And he says, well, the behavior is impacted by driving forces and by counter forces. And if you want people to change their behavior, so if you want scientists to change the way they're doing science just as well, you can drive them more. You say, oh, you know, this is a problem and you should do it differently, and this is wrong, and you've been wrong for 20 years, and pushing people and that way. Or you can say, well, what prevents them from changing? What prevents them from adopting different ways of doing research? Do they lack the knowledge? Do they lack the resources? Do they lack the self-confidence? Are they afraid of making mistakes? And that's a much more productive way if you want people to change their behavior. And so how to regulate workplace behavior is an important question also in what we do with the regulators. And here's one of our students who did a literature review looking at studies that focus on the impact of regulation efforts. And the regulators that we work with, they are mostly trained according to what they call the deterrence perspective. So their main implicit theory is you can make people stick to the rules by threatening them with sanctions, and so the threat will be more effective if the chance of getting caught is higher and if the sanction is higher. So that's all rational choice reasoning, if you wish. And so this is a very strong belief. And what he found when he looked at the studies of what actually helps people comply or what actually relates to even ethical spillover into behaviors that are not regulated but are also in the spirit of the same law, it wasn't the deterrence that was most effective, it were inspections. And what does it mean, inspections? Is an expert comes to you, your workplace, looks at what you're doing and says, well, I see that you're doing it like this, you could also do it like that. Or do you realize that this is not according to the regulation? This is what you have to improve to do it better. I'll come back in half a year or in 1 year to see how it's going. And that was much more effective than this deterrence approach with sanctions and getting caught and increasing the cost. And why was this the case? Because these inspections were more likely to engage with the psychology of the professionals, where they thought, oh, this is something I can do, or oh, I need to think about why I do this, or they think, okay, there is opportunity to make change, or there's if I make a mistake, it's not that I get the sanction immediately. They will understand me, they will help me improve. And so the psychology of behavioral change is just as important if you're trying to change the behavior of researchers and learn from these insights, I think. My personal experience was with an adversarial collaboration. There we had 5 different models of how people form impressions of others in the social world. And all these 5 models had bodies of evidence that were very contradictory. And we got together and said, okay, we need to collaborate because we need to find out what's wrong here and what's going on. And what we did, actually, we organized our collaboration according to the 5 steps of the Harvard model of conflict resolution, based on evidence of what people need in a multi-party conflict negotiation. And so what you need to do is separate the people from the problem. So if there's a problem with the data, it's not that you're a bad researcher, there's something with the data. That's a different discussion. We tried to capitalize on curiosity, so we had different findings. And instead of saying, okay, if my findings are right, your findings must be wrong, we said, hey, that's interesting. We thought we were examining the same hypothesis, we get different results. What could be the explanation? And we went into the details of the experimental procedures, and we found out that we did it in a slightly different way, which was meaningful in the end, and generated new predictions and new research that we could do to examine that. We acknowledge that different people focus on different things, and it's not just right and wrong. We need different people to do different types of research in order to advance in this empirical cycle. And we encouraged each other to take our own theory and put it on somebody else's data to see whether we could explain what somebody else was doing with our pet theory. And that opened up our thinking. And we were very much aware that if the 5 models do not come to some kind of agreement, then we would just erode the trust in all the science that we're doing. And so we, in the end, we found a way of doing this, which generated new predictions, which yielded new theory that we were able to publish about. We got grants to do these new studies. We had a second and a third circle of researchers who were enthusiastic about being part of this initiative and working with that. And so it was much more intellectually generative exercise of trying to reconcile these differences and trying to find out why we had different data studying the same effects, much more productive than saying, if my theory is right, then your theory must be wrong, or if my data are correct, then your data must be some problem with it. And I think this is the way to go, and I find it very inspiring to work in this way. And so I think it is possible to combine rigor and relevance if you are able to broaden your perspective beyond thinking somebody is right and somebody is wrong, or the facts are right, the facts are wrong. I think it's very important to triangulate for theory building, not just only repeating the same study again and again, but also try to see, okay, where are perhaps hidden moderators, where are perhaps certain nuances in the study or the way it was conducted that can explain this, and how can this yield new insights? I think it is important to benefit also from data exploration, so not just hypothesis testing, but also hypothesis generation. And to be frank, in my area of science, I think a lot of what we do is much more exploratory and descriptive than hypothesis testing. And if we just acknowledge that, then there's not so much of a problem, I think, because we should find out what's going on out there. I think it's important, again, for social psychology, not just to have correct point estimates of what's going to happen in a particular situation. I think from my point of view and also from a policy point of view, it's much more interesting to have a theory of change, of what is the cause and what is the effect and what can you change in your policy or in your business model in order to get different behaviors down the line. I think that's much more productive, and never mind how large the effect is exactly, but whether you get an effect this way is much more important for me. And I think it's important to increase understanding of why we find different effects and how we can explain different types of data, because we learn better how to do research and what is going to work that way. And so most importantly, I think we need to close the cycle of evidence, not just develop theory, not just test principles in the lab, can this work this way, but also to see what's the impact in the field and can we make it work in a real rich context where we have a lot of noise going on. So for me, the meaning of doing scientific research is first of all to do justice to the phenomena of interest, and human behavior is super complex. And so you cannot always capture it in a single experimental study. I think it's very important to close the cycle of evidence. So everything that's being mentioned here about statistics and whatever, yes, super important, but please let's not forget about all the other things that we also want to do. I think if we find unexpected findings or cannot replicate previous findings, it's important not just to say this is right, this is wrong, or the facts are wrong, or we don't know what we're doing, but try to understand what is going on. How does this work? Because it's my experience that it generates new ideas and new insights. And I think it's very important to combine the insights and the perspectives and the ways of working. And that's the way for all of us to advance and to become better researchers and to do better science. Thank you.
I'm enjoying myself. I'm a bit more nervous about this part. My name is Albert Menkveld. I'm a professor of finance at the Vrije Universiteit. And my field is very narrow. Like many scientists, we have to specialize. And so I'm looking at securities markets from millisecond to millisecond, where trading robots fight to get the right trade. And usually you have a small crowd of very excited people about this small field. Until I did one study where I joined Anna Dreber and others, where we were worrying about these issues. When you use the same sample and you give it to a different team, would they get the same results? And I thought that was exciting, and we ran an entire project that I'm going to show you a small movie about later. I was just mind blown by the variability that you get if you have people that you respect do the same analysis on the same data, or at least the way they think the analysis should be done. And so it brought me to think about variability. There is variability because you take different samples from a population, but there's also variability in the way you set up your analysis path. Anna talked about it already. And so there's some distance between the sample and the evidence. And so there's creativity on the side of the researcher to bridge that distance. This is the Academy of Science, but this is also the Academy of Arts. And in some ways, the same thing happens in art. Because if you take, for example, music, you can put all of that music in notation on a sheet, but you haven't delivered the piece yet. You need an artist to come from that notation on the sheet to the performance. And there's a lot of degrees of freedom that get you a very different sound potentially. And so I'm very excited that in this panel, not only do we have a Nobel laureate from the Academy of Science leg of this organization, but we also have an artist from the Academy of Arts. And she will show us how that distance is that to be crossed from the notation to the actual performance is quite something. So I'm talking about Claron McFadden. She's an American soprano, has a degree from Eastman School of Music in Rochester, I think that is. And in 1984, she graduated with distinction. That's also the time where we are actually blessed that she came to Holland, and she's currently residing here. She's performed in many, many different places, like the best places in the world, I would say. Of course, here, the Dutch National Opera and Ballet, but also the Bayerische Staatsoper and La Scala in Milan. She's been everywhere. She's been singing at the inauguration of our king, so that's fantastic, I think. But also sitting down and discussing with Robert Dijkgraaf. She was discussing with him the chaos, structure, and parallels between the arts and the sciences. And so she's really the one to have at this conference. I'm really happy that she's here. She's credited for making original choices in terms of repertoire and presentation, feels at home in various genres of music. So she's seeking a blend between classical music, but pop, jazz, non-European music, everything really. So without further ado, Claron, the floor is yours. Thank you.
Thank you. Thank you very much. I'm very, very happy and honored to be here and to share a little bit of what I do. You pretty much said everything. I just will say that the reason I think I'm here is because I asked the question once on a BBC radio thing. They were asking each of the panelists, we were discussing the economic situation in the world, and this was a long time ago, and I wasn't paying much attention, but now I'm glad I paid a bit of attention so I could sort of follow what was going on here. But they asked each of the panelists to make a pitch for how to make the world a better place. It's a 60-second pitch. It could be sustainable, it could be not fictional, it could be anything. And I said, my pitch was, if everyone in the world should start eating at exactly the same moment, for exactly 10 seconds, there would be absolute world peace. And to my utter shock and surprise, they actually picked me to give my pitch. So that started me thinking about what connects us on some level. Of course, music, eating, art, science, ideas, everything, but still there's something that's going on that is just like the brain is muted. So that's something that I want to continue while I'm here. So anybody who's interested in that, please come and talk to me after, because I would love to have some insight and input. So my basic my feeling, or the thing that drives me, is what connects us as human beings. It's in all my work, in the way I approach music, also projects I've done, from putting secret boxes in places, especially where senior citizens or people who've been on the earth a bit longer, where they hang out, and I ask them, give me your stories, give me your secrets, and I will give them a voice. Because for some reason, secrets seem to only really come to life when we voice them. And on another thing that I did was also connected to this 10 seconds of silence was I went around the Mediterranean and with a documentary maker, and we used the aubergine as the kind of visiting card. So I spent a few days with people, and each of them taught me a song in their language, and they taught me a dish with aubergine. And I had to cook the dish, and I had to sing the song in Arabic, in Turkish, in Greek, in Bulgarian, in Sicilian. But what I noticed is that we were all connected with telling stories, so it was about identity. And I asked everybody, if you had to leave your home, but you had all the time to think about what you had to take with you, but you could only take one suitcase, what would you put in it? And I recorded children who were 12 who said, can we take our teacher? There were some people said, I would take a suitcase full of spices and things to share with other people. There were some that said, I would go with an empty suitcase because I want to be enriched by the cultures that I find along the way. I went in the park, I was jamming with, I don't know if they were drug addicts, I don't know who they were, but they were a little bit dodgy in the park in Madrid. It was wonderful, but also quite emotional, because there was one man, he was serving breakfast in the hotel in Istanbul right after the attempted coup, and he had such an open face, so open, and my colleague said to me, He was studying liver cancer research. That was his specialty, but he had to flee his country because he is gay. And I was intrigued by him, so I interviewed him as well. And this whole journey became this piece called Nachtschade Aubergine, which I think is really wonderful. So I'm very inspired to be here. I wanted to share that, but to say also that it's led me to really think about what connects us and what is the power of art, what is the power of music to build bridges, to heal things. So what I wanted to do is to share with you a bit of my work here, because this is a sheet of music. It looks like a chicken ran into ink and then ran over it. I had to do this piece by Brian Fernie Howe, and I was terrified, absolutely terrified, because I had no idea how to read this, actually. And I had a session with him, so I was even more terrified. And the first thing he said was, "I'm so happy that you are performing this piece, or that the piece is being performed." I'd like to think he said "you" with emphasis, but I'm sure he didn't. And then I asked him, there was one particularly difficult passage where I'm sort of doing, that kind of thing. I never could get it. So I asked him to do it 7 times in a row, because I wanted to see if he did it 7 times in a row, if he actually knew what he'd written. He knew what he'd written. He did it 7 times in a row. And secondly, I thought, I will just learn it as a gesture. I'm going to memorize what he did. I'm going to separate my mind from the actual notes that I see, and I'm just going to do like a child. You just memorize the gesture. Then I did it again. It was better, but still not, And then there was a long silence. I was sweating like crazy. And then he said, "I'm very fascinated with the movement of winged insects." And I went, that's it. That's his code. That's his muse. That's his logic. That's his inspiration. And I thought, okay, next time I do this piece, I'm going to have this image of a giant fly on something going. And he went, yes, yes, yes. So that started me thinking, what is the relationship between what's on the score and what's in the mind of a composer? And then how does that get translated by a singer or an interpreter? So I started to try to understand the logic of different composers. Some of them, you think, okay, it's the same set of notes, the same accents, the same everything, but then you think, this person, I think, listened to a lot of 1900 or 2000 pop music. I think this person very much is fascinated by jazz. I think this person likes winged insects, all these different things. So that's how I'm approaching my art. So this, if you can look at it, it's just a background, but imagine a big fly on something, and you'll get... Okay, so what I wanted to do with you is to share another piece, a piece that's very close to my heart, and it's by John Cage. It's called Aria. It's a graphic score. You can, yes, please, maestro. So basically what he says is there's a structure. There's a very clear structure, but within that structure you have immense freedom. So there are certain rules. Each color has a certain style. Kathy Barbarian, he wrote this for her. Pop, rock, folk, operatic, anything like that. And you assign each color a different style. And you see there are words in Russian, in French, in Italian, in English, and in Armenian. So you basically follow the structure, as you can see, and you stay as clear as possible to the structure, but it can be this big or it could be this big, but you respect the structure. And then there are these blocks that he has written, and these are any non-vocal use of the voice or the body. So what I wanted to do is to show how the magic happens in between the notes, in between the gestures. I mean, there was a mention of under the iceberg. That's what Robert Dijkgraaf and I were talking about. What happens under the surface. That's where the magic happens. So what I would like to do is 2 complete versions of this little excerpt. One I will do the way I normally do it, or often do it, and then I'm going to do a version after that's completely different, still respecting exactly what the structure is, but very different. I've asked my colleagues for some input, so there will be some very specific jazz things popping by. Certain animal sounds will be popping by. So there it is. This is John Cage's aria. Zoom di rui di questa terra na prosno conscience Vigela facilmente ed io sono per te. No other way dans l'espace, si help, si just dvidzenia bystri. Un po' grasenetiotoko. Si io ti tengo lontano. Ciao! Glubinoi più chiara, sì, sarà, e se si cucù, totalmente suoi, onde so tu slay. To have the fruits gloire, j'écoute la vie, leggermente snoi. Banalité. Go. In So you heard there was jazz, there was trillo in Renaissance style, there was Edith Piaf, she came by, there was all kinds of country and western, computer, coloratura, Sprechgesang. So now the one that's a little bit more maybe dystopian, I guess. Zem. Conscience. Vigela facilmente. No other way, no less no help. Cela est ceci. Totalmente soy un desadusley. To have the fruits gloire. In harmonia.
Bravo. Thank you, Claron. So who's going to sing next? So the next vocalist here is Guido Imbens. He's a member of the Academy of Science, and in high school, Imbens was, as I browsed through all the information, he was very impressed with Jan Tinbergen, the first Nobel laureate in economics, who co-founded the econometrics program in Rotterdam. Guido went to the econometrics program in Rotterdam. He graduated from there, and then there's a long way up the economic ladder, and he eventually got the Nobel Prize himself for work he did with George Angrist, methodological contributions to the analysis of causal relationships. So Imbens worked with Angrist and with others. Was credited with catalyzing the, and this is important now, credibility revolution. I'd like to underline that. Credibility revolution in empirical microeconomics. He holds the applied econometrics professorship at Stanford Graduate School. I said that he was also a member here, but he's also a fellow at the Econometric Society, the American Academy of Arts and Sciences. Guido, you know about the choices of editors have to make. You're an editor at the Econometrica, one of the best journals in our field. And so one thing I wanted to mention, which I always like to look for, what sets this person apart from all these other great people that we have. And one thing that struck me was on the day that he got the Nobel Prize, and that, as you know, is a phone call that you get in the morning, and it's very early if you live in California, from Sweden, that massive event, of course. You won the Nobel Prize. And he was kind enough to address all the people that wanted something from him, but he said, it can't be that I have to miss the presentation of one of my students in a seminar he's giving around lunch. And this much he cares about the new generation and all of us, essentially. Guido, the floor is yours. We're happy to have you.
Thanks very much for inviting me to speak here at today's conference. Now, after Claron's talk, because I'm terrified here when I was in, I think, 2nd or 3rd grade in elementary school, my one failing grade was for music, and in particular for singing. So I was totally in awe of the previous speaker, and so I am not going to sing. But I'm very happy to be here. I'd never been to the Trippenhuis when I became a member of the Academy. The building here was being renovated, so the ceremony was in another building that wasn't nearly as impressive as this venue. And so it's a particular pleasure to be here in the Timbergen room. Timbergen was a great role model from my perspective. His work influenced me when I was in high school. It made me study econometrics. So what I want to do is, so I don't actually have, I didn't make slides. I thought a lot about what I actually wanted to say, but this also gives me an opportunity to talk about some of the issues that were raised before. And so what I want to talk about is some of the issues in this area and reflect on some of my own experiences. And so my experiences come from my role as a researcher in economics and related fields, but also as editor. On the editorial side, I was the main editor of Econometrica, one of the leading journals in economics for the last 6 years, and I actually just finished my term at the end of June this summer. And that was a very interesting experience. You get a lot of interesting papers, some not so good papers, some really weird papers. The weirdest one actually was I got a paper that was talking about the way economists tend to discount the future. Kind of a lot of economic models where we put more value on the present than on the future. We kind of discount that by about 10% or something, or 5%, and future years even more. And this paper was arguing that we got that all wrong. The economists got that all wrong. You may think that this person was going to argue that we should place more value on the future and make sure that we don't screw things up for future generations. But actually, this person was making the opposite argument, that we should not pay any attention, put very little value on the future. And so the implication of that would be that we should just pollute away and not worry. And so the specific argument for why we should do that was, well, there was going to be some chance we would invent time travel, and then we could just come back and fix all the problems. So I looked at a paper and I said, well, and I wrote to the author saying, wow, this is very interesting. This is not really the kind of stuff we're looking for in this journal, so we're not going to publish this. But then I couldn't resist. And I said, well, because there's a chance I'm wrong on this, but really that's not a problem, because if I'm wrong, I'll just come back and publish the paper later anyway. I was impressed with Eric-Jan's setup for this new journal, where he was going to limit things to 500 words per submission. One of the things that I didn't like at Econometrica when I started was the average length of the publication had actually increased greatly over the years. In the 70s, it was about 12 pages. And when I took over as editor, it basically increased every year. And by that point, it was about 36 pages. And in fact, at some point, we published, before my term, we published a paper that was over 100 pages, kind of pure theory. And so I thought I was moving in the wrong direction. So I set up a page limit for submissions of 45 pages. That was kind of in double spaced. And so that would actually correspond to about to a little less than 30 pages in the journal. But I said, submissions kind of got to be 45 pages or less. And so in general, people were kind of happy with that, but people were happy with that as a general policy, but typically not for their own papers. And so once actually I got a very senior person who sent in an 80-page paper, so I sent it back saying, well, no, we're not doing that. And then he wrote back saying, well, it's a very important paper. It's got long and difficult proofs, and if Econometrica is no longer interested in that, that's really undermining the foundations of the econometric society. And it's but if you're going to reject it for that reason, fine. And so I wrote back, and I was probably advice. I said, well, what we're looking for are papers with interesting results, and I don't really care whether the proofs are difficult or not. That's not really part of how we make the decision here. So then he as I said, that was probably not a good idea. But, so he wrote back. At that point, he got very annoyed. He said, well, this is terrible. And so he wrote to the president of the society calling for my dismissal as editor. And so then I got a very lucky break. It was Monday, October 11th, 2021. I got a call from Stockholm. And so 2 days later, the president of the society wrote to the author saying, well, we thought about it, but we'll keep Imbens as the editor. But part of that is sort of I did try to make some of these changes at Econometrica, but these journals are often hard to change. And so I think there's a lot of things broken in the publication process in sciences in general. I think we've been way too reluctant to actually innovate. So one of the other things I did kind of reflecting on Anna's comment, once we actually did publish a paper based on review kind of before the results. There was a team of authors that approached us. They wanted to do a paper using data from the Econometric Society itself, data on the election of fellows. They wanted to see if there were issues kind of with the election process, whether there were groups that we were being discriminated against. And we were open to doing that, but I didn't want to have the responsibility of deciding whether to publish that paper based on the results. It kind of clearly would look very bad if I decided to not publish the paper because the paper suggested that the society was engaged in discrimination. Of course, it wasn't necessarily reflecting on my personal choices, but it would look bad for the journal if the decisions were made based on the result there. So we set up for that particular the paper a special process where they wrote the paper without the data. We gave them the format of the data. They wrote the paper kind of in terms of the tables they would produce and everything, other than not having seen the results. And I had it refereed on that basis, and we accepted it. Then they were given the data, and then after that I edited myself, kind of just in terms of the writing, but not in terms of the results, which at that point it was guaranteed to be published. Now, not to make to disabuse you of the notion that I was doing everything right there. There was actually a discussion about whether we should have a second group of people analyzing that same data. And so we did, in fact, have a second group also write a proposal. They didn't do a particularly thoughtful job, and so I did not accept that paper. I was kind of not quite sure at that time what to do with that. I thought there would be value in having a second team kind of look at exactly the same data, kind of from a different perspective, and doing an independent analysis. But I did not accept that proposal, and I have some regrets about it. I think the idea of having multiple teams analyze data, I think is a very useful one, and that's something we should try to do more often. Now, last week actually, I read a interview with Cass Sunstein, a legal scholar and behavioral economist at Harvard. At some point, he was asked about the replication crisis in behavioral economics, and Sunstein doesn't think we have one. He was arguing that what we have is a replication challenge, as I would call it. I wouldn't call it a crisis. What's happening in Gaza is a crisis. Climate change, in my view, is a crisis. And so I totally agree that Gaza and climate change are real crises, and I can easily name about 10 other problems that are much more serious than what's happening with replication in social science. But I do think Sunstein's comment is a little glib. We do have a problem, and as scholars, as the academic community, we should really address it. We should try to improve the practice. Science is important for solving what even Sunstein sees as real crises like climate change. And making sure that science is credible is key to solving those problems. And I think we've lost some of that credibility in recent decades. To be more specific, last year I was teaching a class, an MBA course at the business schools at Stanford on data science and sustainability with someone from the Stanford School on Sustainability. And in that class we had a couple of energy executives giving guest lectures. And so in the energy discussions in California, there's a lot of focus on flattening the variation in within day energy demand over time, what's called flattening the duck curve. Because the within day shape of the demand kind of looks a little bit like a duck. During the day, residential demand is very low, and in fact, it's so low that prices are often negative. We have a lot of solar energy there. I'm always impressed here in the Netherlands how many solar panels I see here, given that the weather isn't always cooperating with that. But in California, they work really well. And so energy prices during the day are often negative, but at night, it kind of peaks. It goes up very sharply when people come home and they kind of all start charging their Teslas. Well, not the Teslas anymore. They're not quite as popular these days as they were a couple of years ago. But prices do go up very sharply, and that creates a huge amount of problems, because that's when they use the coal plants, and in fact then they have to have the coal plants running all day to make sure that they can work at night. And so there's a huge amount of value to flattening the demand curve. If you get it averaged out, then prices would be very close to zero. We wouldn't need a lot of the coal plants. And some of the behavioral focus, kind of nudge incentives of the Sunstein-Thaler type may very well be effective. We may be able to convince people not to charge their cars immediately when they come home. They don't actually need their car to be charged fully by 7 o'clock. They just need the car again in the morning. So it's fine to charge it at 4 or 5 in the morning. But people tend to just plug them in immediately when they come home, and they're not incentivized to kind of delay that a little bit. But for those cases, we don't need to, and this goes back to some of Naomi's, but we don't need to test whether these particular incentives would actually have some effect, whether there's some effect there, and whether the p-value is 0.05 or 0.01 or 0.03. What we need to know is actually the magnitude of these effects. We need to figure out how we actually flatten the demand sufficiently over the days. And so what we need is get precise estimates of the magnitude of these effects that replicate, unlike some of the results that we've seen in behavioral economics with some of these incentive experiments. But so I want to start kind of by making a distinction between these two problems, and this has come up a little bit before, kind of deliberate that has led to some of the mistrust in science. Some of the deliberate misconduct versus sloppy or poor science, and thinking about rules and practices that may help with those problems. In economics, there have essentially been no retractions of academic papers in leading journals till a couple of years ago. That just didn't really happen. In other disciplines, there have been regular retractions over many years, but in social science in general, that was just very, very rare. Now, kind of one sunny view of that is that social scientists just write better papers, but that seems very unlikely, and certainly sort of in my experience as editor, that doesn't seem to be the case. Now, in recent years, there have actually been some retractions in leading economics journals. So why did that change? Clearly, a big part of that was the requirement that many of the leading journals in economics now have in place, that authors submit replication packages, kind of including both the data they use and the code they use to run to get to the results. And in most of these journals, they actually have special data editors that then run the code to see if the numbers in the papers actually match. And so kind of in one of these retractions, that really played a big critical role in the retraction. This is the one in the American Economic Review in 2023. And in the retraction note, the authors wrote, "The code that plots figure 4 in the publicly available code repository includes an alteration of 2 of the coefficients by a factor 1.8, which was incorrect." It's a slightly euphemistic description of what actually happened. There was a remarkable single line of code in the code package that replaced 2 coefficients by 1.8 times their original values. And so that single line of code basically led to the retraction. There was no reason why that line should have been there. There was no explanation in the end that was given why that line should have been there. Now, that type of behavior may be relatively rare, but not quite as maybe not quite as rare as at least I thought. 2 years ago, I was on an advisory committee asked to review a particular hire, and on this person's CV was a retracted paper. I was kind of curious about this and dug into that a little. It turned out that one of the co-authors on that retracted paper had themselves more than 15 papers retracted over the years. Now, I can totally understand that someone may have made a mistake at some point and that a particular paper got retracted, but 15 sounds like extreme carelessness or more likely deliberate malfeasance. Of course, there's other examples. There's the resignation of the president of Stanford University almost 2 years ago, after it was discovered that in some of his papers, images, which was the basic data in their analysis, had been altered. Apparently by a postdoc, but ultimately that came with a very heavy penalty for the then president of the university. And in my view, rightly so. As the director of the lab, he was responsible for the culture in the lab. And if, as it appears to have been the case, there was a culture where junior researchers felt pressure to come up with significant results, clearly the leadership bears responsibility. And of course, there's other well-known cases where researchers appear to have deliberately misreported their work. The infamous Francesca Gino case comes to mind. Yesterday on the plane, actually, I was reading the book by Max Bezeman, Inside an Academic Scandal, a story of fraud and betrayal, that just came out on September 9th. Bezeman was a co-author on one of the Gino Ariely papers that got retracted for having multiple data problems. The paper, for people not familiar kind of with the overall story, was about the value of asking people to be honest at the beginning of filling in a form rather than at the end, with the idea that if you make people aware that they if you impress on people that they should be honest in their reporting early on, that may have a bigger effect than doing that at the very end when they've already filled in the form. And one of the studies in that paper by Dan Ariely had data that looked like they were at least partly made up, and the second one where Gino was responsible had similar problems. The book's actually a fascinating read on that scandal that again has come with big consequences. So far it's cost Gino her tenure job at Harvard, and there's still ongoing lawsuits within the latest. Harvard University actually suing Gino for defamation. Another very interesting, very recent case of outright fraud is from a former MIT graduate student. He wrote a paper that got a revise and resubmit decision at one of the leading economics journals, the Quarterly Journal of Economics, which is of course extremely rare for a graduate student. And in fact, he wrote this paper partly before he was even in the graduate program at MIT. The paper also generated a story in the Wall Street Journal with the headline, "Will AI help or hurt workers? One 26-year-old found an unexpected answer." And so if you look up the article, there's actually a photo in the article showing the author with two of his MIT advisors, Daron Acemoglu and David Autor. It's not surprising that the Quarterly Journal of Economics wanted to publish the paper. If that paper had been submitted to Econometrica when I was the editor there, I'm sure we would have been very interested in it, and I'm not quite sure we would have discovered the problems. I would like to think so, but it's a big challenge. If you look at the paper, it's an amazing piece of research. And at that time, people were desperate to see evidence of the effect of AI on real outcomes, which made it even more intriguing. Because at the moment, if you go around Silicon Valley, if you drive from the airport back to Stanford, there's billboards everywhere, kind of with all these AI companies and what they're going to do and what they're going to deliver. But there's still very little evidence that AI actually really helps productivity. Daron had written a paper, I think about a year ago, suggesting that the effect of AI on GDP over the next 10 years is going to be on the order of 1 or 2%, far less than what some of these companies are claiming. There's now some evidence that it does affect things in particular professions. Call centers is one case where it's shown great increases in productivity, but there's a lot of other cases where it's really hard to imagine it doing very much. When we're trying to build a house, we still need actual people doing the building, and so this paper kind of was claiming to show evidence that there were actually real effects in jobs that really mattered. What the author did was analyze data from a randomized experiment at some chemical company, where the idea was they had 1,000 people, 1,000 researchers working on coming up with new 1,000 material science researchers trying to come up with new materials, and some of them were given access to new AI tools. And the author tracked the effect of these tools on a bunch of outcomes: the number of new materials discovered, the number of patents filed, the number of new prototypes developed on the basis of these new materials, and kind of all of these things showed great effects. And in fact, the author went way beyond that. He used a really impressive seeming methodologies. He calculated the quality of these new materials through an elaborate algorithm that measured the distance between these the distance from these new materials to the target properties that they were trying to get to. He measured the structural similarity of the crystal structures of these new materials by calculating differences in atomic positions. So it really looked like very, very impressive stuff. After a while, however, some people started questioning some of the results, some of them material scientists, and ultimately also the person's advisors. And you know, it wasn't in principle so hard to figure out where these data must have come from, given that there's not a lot of companies that have more than 1,000 material sciences researchers. And people were also questioning why a company would actually give access to such confidential data to a graduate student. And it turned out in the end, you know, before he was even in graduate school, it turned out it was all made up. He even set up a website called corningresearch.com that he used to send emails to himself, to his MIT email address, kind of documenting the exchanges between the research team at this company and himself. And in the end, that was one of the things that got him into trouble, because the Corning got concerned that there was this website that was not actually associated with their company, pretending to be done. But before kind of thinking about what, and some of this is going to be somewhat limited, but before we can thinking about what we can do with the outright fraud, let me also make some comments on the other type of behavior that is a concern. Not outright fraud, but poor science. And here, similar to Anna starting with her own research, where she wasn't very happy exposed with it. So here, let me also make a confession. When I was in graduate school, I was working as a research assistant, was doing consulting on discrimination cases. And so essentially here, this person would be asked to analyze data showing that one group had different outcomes on average than another group, possibly after adjusting for some differences between these groups. And I had to implement the particular tests that he that he thought up. And so what I was asked to do in that case was for any particular hypothesis, I was asked to do 3, 4, 5 different tests, just till there was one that was supporting the results the person was looking for, and then I think the person asking me to do this didn't really think of that as bad science. I think they thought of it as just being creative in analyzing the data. Somewhat kind of the same way I remember a long time ago during the O.J. Simpson trial, Olin Dershowitz would argue that likelihood ratio tests were particularly poor choice of methodology and unprecedented and totally inappropriate. And I think he viewed that as just that was the way you would make the case for whatever argument you would make. And you wouldn't really think of the statistical methodology as something that comes with rules in the way you would use them, but just as another way of using language just to support whatever things you're trying to do. Now, and here's a quote from one of my favorite papers in economics, one that had a huge influence on my own research, and it was part of the inspiration for the credibility revolution that Josh Angris, David Card, and I participated in. This is from Ed Lemer's paper, Let's Take the Con Out of Econometrics. And so this is a fairly long quote, but I think it's worth it. Lemer writes, econometricians would like to project the image of agricultural experimenters who divide a farm into a set of smaller plots of land and would select randomly the level of fertilizer to be used on each plot. If some plots are assigned a certain amount of fertilizer while others are assigned none, then the difference between the mean yield of fertilized plots and the mean yield of unfertilized plot is a measure of the effect of fertilizer on agricultural yields. The econometrician's humble job is only to determine if that difference is large enough to suggest a real effect of fertilizer, or is so small that it's more likely to be due to random variation. And then he goes on. So this image of the applied econometrician's art is grossly misleading. I would suggest a more accurate one. The applied econometrician is like a farmer who notices that the yield is somewhat higher under the trees where the birds roost. And he uses this as evidence that bird droppings increase yields. However, when he presents this finding at the annual meeting of the American Ecological Association, another farmer in the audience objects that he used the same data but came up with the conclusion that moderate amounts of shade increase yields. A bright chap in the back of the room then observes that these two hypotheses are indistinguishable given the available data. He mentions the phrase identification problem, which though no one knows quite what he means, is said with such authority that it's totally convincing. The meeting reconvenes in the halls and in the bars with heated discussion whether this is the kind of work that merits promotion from associate to full farmer. The Luminists strongly opposed to promotion and the aviophiles equally strong in favor. Now, one of the things is this paper was published in the American Economic Review, and one of the things that when I was editor would keep me awake at night is whether if I actually got submitted, if I had a submission like this, whether I would actually be brave enough to publish it. And I think, again, one of the challenges is actually taking risks as editors and doing new things, and we're not doing clearly enough of that. But kind of back to the Lima quote, my experience is that in biomedical settings, things are quite different, and that they treat p-hacking essentially as fraud. Of course, part of that is that the grass on the other side may always seem greener, but there's clearly differences. In medical trials, you cannot simply drop some individuals because there's some missing data. You need to account for all individuals in your original population, every single one. You cannot change your outcome variables just because you did not find any results for the ones you originally set out to focus on. Let me give two examples of that. Once I got asked by the Food and Drug Administration to serve on a panel to analyze a randomized controlled trial for a new drug that was in process. As is common, the researchers had actually specified primary outcomes and a number of secondary outcomes. But while the trial was going on, they found that there was a statistically marginally significant difference in the outcome. They had not pre-selected for analysis either as primary or secondary. And normally that would mean that they wouldn't be allowed to bring in such outcome as evidence, and that would be the end of it. However, it was a very important outcome, mortality. It turned out that in the treatment group, more people were dying, sort of marginally more statistically significantly more people were dying in the treatment group than in the control group, which they had not anticipated. There was some mortality expected. This was a very ill population of individuals, but still there was a big concern that now actually mortality was different, and so this really mattered. Some of these people were dying, and the question was what to do with that evidence, given that if you said, well, if you're going to be looking at these p-values all along the way, you should do multiple testing adjustments, and then it wouldn't have been significant. But in the meantime, there were people getting this treatment, and there was some chance that these were actually dying. So the FDA's decision was kind of to bring in a panel of experts that included people who knew about the medical condition. There was a lot of discussion about whether it was, in the end, given that it hadn't been anticipated, whether there was any pathway through which they thought there could be some effect on mortality. There were a bunch of statisticians and people with expertise on the experimental design and how to analyze this. And in the end, the decision was made to stop that trial in the middle. Second example, and this is one I use in some of my classes. This is from 2002. The CEO of a medical company, Harkonnen, sent out a press release with the headline, Intermune announces phase 3 data demonstrating survival benefit of Actimune in IPF. And the subheading, in case this wasn't clear enough, reduces mortality by 70% in patients with mild to moderate disease. Content said that Intermune announced today that the preliminary data from its phase 3 clinical trial Actimune injection for the treatment of idiopathic pulmonary fibrosis, a debilitating and usually fatal disease for which there are no effective treatment options, demonstrate a significant survival benefit in patients with mild to moderate disease randomly assigned to Actimune versus control treatment with a p-value of 0.004. And that wasn't quite right, but it was very effective for this company, and their share value went way up. But they hadn't really pre-specified this particular subgroup with mild to moderate disease. And the overall population, studied population that included the people with severe disease, the people with no symptoms before, wasn't significant, had a p-value of 0.52. So in that case, Harkonnen was actually charged with 1 count of felony misbranding, 1 count of wire fraud. He got acquitted of the felony misbranding, but he did get convicted of the wire fraud. And a little later, a much bigger, much higher powered trial, again, as what Anna suggested, was done to see what the effect was, and it turned out there was no effect for that moderate to severe disease group. It was all coming from the fact that they just looked for groups desperate to find some effect, given the anticipated huge implications for the company. And I would submit that this type of p-hacking is quite common in social sciences. And while it's not good in social science, we don't send people to prison for this, and people don't lose their jobs over this, in contrast to some of what's happening in these biomedical settings. So what can we do about this? I want to discuss a couple of specific things, but before I want to be clear about the problem we're solving. While there are these really intriguing and interesting cases of outright fraud, I think that's in the end quite limited. It's probably more common than we think. It is the very curious thing that the Gino and Ariely papers seem to have 2 authors who both engaged in these practices independently and ended up working together, which seems either a very unusual coincidence or suggesting that the practice is more prevalent. But in the end, I think this is not a very common thing. Is kind of similar with the MIT student case. I think the returns to actually committing fraud in academics are very low. If the MIT case seems at some level more of an artist, of a con artist, who's actually incredibly skilled in doing this, and there's much better returns for that type of skill outside of academics. It's not quite clear what the long-term plan could possibly have been. In the best case scenario, he would have gotten his publication. He would have had a great graduate student career. Based on that, he would have gotten a great job at a top university. But there's still the rest of your career to think about, and how you're going to actually do good research after that is not clear. And committing this type of fraud repeatedly is just very unlikely that would be a sustainable thing. So I think that's actually very rare. And so what the goal should not be so much as coming up with structures that make it impossible to commit fraud, but make it harder on the margin to commit fraud, and to make sure that the penalties in the low probability event that you get caught are reasonably high. And I think on the latter, we're already there. And in fact, the penalties may be a bit too high, partly because the probability of getting caught is so low. If you kind of think about the American Economic Review retraction, where the person had added the line of multiplying the coefficient by 1.8, the author has lost their current job, and I think it would be very hard to get a job at a serious research institution. the Stanford president lost his presidency there, kind of for the data manipulation that been going on. Gino lost a tenured position at Harvard. So I think, from my perspective, I think it would be better if we were better at catching these cases and wouldn't have to impose these penalties where people essentially lose their entire careers over some of these things, where there's a lot of people probably getting away with it without any penalties. But so what can we do? So I do think pre-registration pre-registration is very helpful. This was initiated in economics by the American Economic Association for their journals, but this has now been adopted by some of the other journals, including Econometrica, when I was editor. So actually, I think it's starting now in January, but the decision was made while I was editor. And in that we included both field experiments of the type common in development economics, but also the lab experiments from behavioral economics. And interestingly, there was actually a lot of opposition among behavioral economists to setting up these rules. And I spent a lot of time talking to the people there to understand, when we were making this decision, what their concerns were. One is that they felt that while there had been problems in behavioral economics, these were not economists themselves, and they felt that there was no evidence of this happening in the economics profession itself. Second was that it wouldn't really help, that it wouldn't really do, because people could do lots of experiments. There was some argument that it wouldn't really help prevent fraud. And so they felt it would just impose costs on researchers. Behavioral experiments are often sequential, where someone does one experiment, and then depending on the result does another one, and then a third, till they kind of get to an experiment that they feel makes the things they're interested in particularly clear. And kind of related to that cost, one experimental economist told me that he really values the ability of actually thinking of some idea and then implementing it the same day, and not having to worry about pre-registering and taking all these additional steps. And I was particularly unsympathetic to that last argument. I think it would actually be very helpful if people thought very carefully about the experiments they were doing and spend a couple of days thinking through what the analysis are that they would do, and make sure that it all hangs together. In the end, the fact that someone had done a bunch of experiments before the final one, even if they analyzed the final one exactly in the right way, would be very helpful in making a decision whether a particular finding is credible. And so in the end, we did decide to go ahead and kind of insist on pre-registration. And certainly that would have helped in some of the Ariely cases, where in one of the papers there's now an experiment where nobody actually knows where it was carried out anymore or who actually carried it out, but these data were passed on from one researcher to another, and the overall history is unclear. Second strategy to deal with the fraud, I think, is replication packages. And so this is something that the number of the economics journals, again, have instituted the last couple of years, including at Econometrica. And that has clearly led to some retractions, where exposed people could look at code and kind of realize that the results didn't really hold up, and that the data were analyzed in a way that was not appropriate. We're not there in terms of having this streamlined and efficient. I just had a paper of my own, kind of handled by one of the journals that does have a replication policy in place. And even though we had a package that worked, that seemed to work very well, it seems to take an extraordinarily long time to actually get it through that process. There's all sorts of issues these days with different versions of software packages that are being used, and even different the hardware that's being used to run these programs. And this is going to be even more of a problem in the future when people are using AI, are using large language models to do some of their research. Different versions of these large language models are going to give different answers. So it may not be possible to create a repository with the code that exactly replicates results in particular papers, unless you take enormous amounts of memory space, so you would actually store the particular versions of these large language models. So we may need to change how we do things and how exactly we approach these kind of very narrow replications. But at the same time, I think they've greatly improved the credibility of much of the research in economics, where prior to this, it was virtually impossible to even narrowly replicate the numbers in a paper using the same data and using the same code as the authors. Forget about all the forking path problems and the choices made by the researchers. Even if you condition on all of those, you couldn't replicate the numbers. And it's hard to argue that results are credible if that type of replicability doesn't exist. So given kind of the way empirical work gets done now and is going to get done in the future, I think preserving the integrity of the entire chain of manipulations may not be feasible much longer, but having some version of this will remain in place, and I think that's a very good thing. Now, there's other challenges with replications, and sort of some of the presentations earlier kind of called for more of these replications to be done. And there was a complaint that editors are not looking favorably enough on these replications. And I think there's some truth to that. As editor, I've reflected on some of these things. But there's a challenge with that. There's incentive in academics, not just for the authors, but also for the journals, for employers, for departments and universities. And these incentives matter. So what are some of the incentives that concern me in this regard? First, there are incentives for researchers to react unkindly to replications that don't go their way. While some of the researchers graciously accept corrections to their work and see the attention it gets as an affirmation of the importance of their work, some see it as a threat and react aggressively. One of my good friends, David Card, for a while taught a class in which all the students had to replicate a published empirical paper kind of based on data from the authors. This is before the data would often be posted, so they would actually have to go to the authors and get the data and get their code. He stopped doing that at some point when on a number of occasions the authors would actually take issue with the students doing those replications and criticize them in ways that appeared quite unprofessional and certainly was very unpleasant. It was a very unpleasant experience for the students. Then maybe that partly was partly resolved by having these replication packages available, so the students don't have to go to the authors directly. But still, in the end, if there's concern that authors are going to react aggressively to replications that are critical of their work, that is going to discourage people from doing that. Another concern was that journals should publish more such paper. And again, that's kind of a tricky issue. As an editor, my charge kind of was to publish papers that would be of interest to the readership of the journal that I thought were important in terms of the science. And for any individual paper, that is more likely to be the case with a paper that's doing new stuff than with a successful replication or with a paper that has null results. And so it was hard to see how I should make more room for that type of papers at the expense of other papers. And so there, having specialized journals doing that may make it easier to get more room for that paper, for that type of papers. Kind of somewhat related is the fact that in the end, researchers' reputation is by and large driven by a small number of their most influential papers. And so it's hard to get incentives right for researchers to put a huge amount of effort into these replication papers. I mean, the research that was reported on here in the earlier presentations takes a huge amount of work. It's just some of the authors, kind of presenters, reflected on that. But these replication efforts are incredibly time intensive, and so it's very hard to incentivize people to do that type of research. And I'm not quite sure how to change that part, other than to pay tribute to the fact that people are willing to do these things. But it's hard to get junior people credit for these things in discussions on tenure, on promotions and hiring. Kind of somewhat related, and that goes back to some of the papers that were mentioned, kind of the ones by Gino, the ones on the power poses. In particular, kind of at the business school, and I'm at a business school myself these days. There's a sense that sort of these business schools often publish these magazines for their alumni, kind of as part of their fundraising strategies. And so these magazines kind of publish lots of stories, lots of articles, often, but some of them are about the research of the faculty. And so what they're looking for there is research that's interesting, that's eye-catching, that is easy to read. And stories like the ones about the power poses, like the ones about changing small things in the form, about moving something from the bottom to the top, are easy to explain. And they make for easy conversation. And so it kind of it does create incentives for people to do that type of research. And I have great respect for the fact that Harvard Business School has taken some of the research misconduct very seriously, but at the same time, they promoted the type of research for a long time very aggressively as well. And so I think there's something in the culture of these places that contributes to these problems. Now, one final comment on that is that there's been suggestions of pre-registering not just experimental studies, but also experimental studies. Of course, that's a bit tricky. In these biomedical sciences, there's very clear protocols for pre-registering randomized controlled trials, where the exact analysis that are planned are described, including the functional forms and the additional variables included, and the subgroup analysis. In social science, kind of the way these pre-registration protocols have been adopted, they're much looser. People essentially write whatever they want, and then when papers are written, people can go back to these pre-analysis plans and see how well they match. But they they're never as exact as in the biomedical sciences. And this is clearly going to be a much bigger challenge if we ask all observational studies to pre-register their analysis. At some level, the problem is about enforceability. If someone plans to do an analysis, well, one problem is about enforceability. If someone plans to do an analysis using the current population survey, which is a public use data set based on a series of cross-section, one could write down the planned analysis, but there's very little to prevent someone from first downloading the data and trying out all sorts of analysis and then pre-registering their particular final analysis. Of course, that would be fraud, but it would be very tempting to do at least some peeking at the data before writing down a full pre-analysis plan, not knowing what the exact structure of the data is, how the outcomes are exactly measured, not realizing what the patterns of missing data and the prevalence of missing data is, makes it very hard to be very specific in the analysis, the way you can do in a randomized experiment, where the analyses are often very simple. And if one is worried that somebody else may be peeking at the data before doing their pre-analysis plans, again, it becomes harder to avoid cheating in some way. At the Graduate School of Business at Stanford, we're no longer allowed to simply disallow the use of AI and large language models for problem sets and take-home exams. And the rationale is that it's not really fair to the students to have rules that are not enforceable and put students in undue temptation if they feel that others can get away with cheating. Now, of course, there may be some ways of rescuing these ideas of pre-registration of observational non-experimental data. You could imagine having the data not publicly available, but putting them in the repositories where someone would apply to get the data and have to write some pre-analysis plan before doing that. And you could even imagine making some synthetic version of the data available so that people could actually figure out what their analysis would look like prior to getting the real data. Because doing so without having at least some of the data would make it impossible to really have a complete analysis plan. And so with some synthetic data, you could imagine people trying things out. Such a strategy would still have problems. A researcher could plan one analysis with a particular data set and then use it to try out analysis for a different question, but it would at least make cheating and misbehaving harder. Now, a third tool to improve and create better incentives for researchers to be honest in their research is to be more transparent about research contributions. In economics, it's common that authors are listed alphabetical with no clarification regarding specific contributions from each of the authors. At some level, that was fine when there were a lot of sole authored papers and very small research teams, but nowadays there's often teams with many researchers where it's very clear that people do different things and are actually responsible for different parts. And in some of the retractions, one unfortunate thing that has happened is that you see some of the authors disclaiming knowledge of particular parts of the papers exposed. There was a retraction in the Journal of Finance where two of the authors claimed the empirical part that led to the retraction was carried out by the third author. And similarly, in Bezelman's book, he claims other authors, in particular Gino and Ariely, were responsible for the data sets that were analyzed in the paper. And in my view, authors should not be able to expose deny responsibility unless they declared at the publication stage that they were not responsible for particular parts. And of course, in medical journals, you often see these very elaborate contribution statements where some people were responsible for collecting the data, some people were responsible for analyzing them. And I think that that division of labor is fine, because in economics that's something we greatly believe in. But I think acknowledgement there would be very helpful. And in econometrics, we now actually encourage the authors, though we don't require it, we encourage them to be very clear about the contributions, and that if they claim, as most papers do, that everybody was equally responsible for the paper, that would also be the case if papers get retracted, if there's problems found with the papers later. Last thing, and this kind of reflects a little bit on the team science idea that Eric-Jan brought up earlier. We should probably not rely on single studies so much in social sciences. And here, one interesting experience I've been involved in was that the National Academy of Sciences in the US occasionally convenes groups of researchers to evaluate research on a particular policy relevant question. I once served on such a committee that was looking at the deterrence effect of the death penalty, because that's a very controversial topic, especially with the way the death penalty is implemented in the US. You could well imagine that there are settings where the death penalty works as a very effective deterrent. During wars, often deserters are executed, and I think desertion is probably a very rational decision where people balance the concern about getting killed in combat if they stay in the army with the possible penalties if they get caught. But of course, for the crimes for which people these days get potentially face the death penalty, these are much more complex decisions where it's hard to imagine people making very rational decisions. There'd been a lot of work in the academic literature on the deterrence effect of the death penalty. Essentially, all of it was making comparisons of the type, how many murders or crimes of a particular type are there in Texas relative to where the death penalty is implemented versus, say, Massachusetts, where the death penalty is not implemented. And because I would find it hard to imagine that people would make their decisions whether to commit these crimes looking forward to the chance, which in the US would take a long, long time, that they might get executed versus life in prison, which doesn't seem like a particularly attractive prospect either. So the relative difference doesn't seem likely to weigh in very heavily on these decisions. But in the end, the analysis were typically all very sloppy, very lacking credibility. These comparisons where people committed crime in one jurisdiction rather than in the other, and arguing that reflected on the deterrence effect of the death penalty. The one study that actually was very impressive there, that found an effect that was statistically precise and in my view very credible, it was by a student of Larry Katz, someone who was sort of very much part of the credibility revolution. This was a study where the author, I forget the name of the author, compared the cases that were handled by the different prosecutors in New York, where at the time when New York reinstated the death penalty, some prosecutors publicly stated that they would not seek the death penalty, even if it was potentially applicable, and other prosecutors did not make such statements or stated that they would be prepared to seek the death penalty. And so the study involved comparisons for people who are, as is common in all these jurisdictions, essentially randomly assigned to prosecutors once the case comes in. And they compared outcomes in terms of plea bargaining. And so what you could see there is that the people who are assigned to prosecutors who were prepared to seek the death penalty were more likely to be willing to engage in plea bargaining and make plea bargains that avoided that than people who were assigned to prosecutors who'd already taken the death penalty off the table. And of course, that's a very different situation, where at that point, these people are sitting in prison. They actually have a lot of time on their hands to think about what the best decision is for them. They have counsel, they have people to talk to about these decisions. And at that point, it's very credible that they're making a decision that actually makes sense from their perspective. And the research design, again, was not comparing people in Connecticut with people in Florida, but it was people in exactly the same areas where there was random assignment, or essentially random assignment to these prosecutors. But kind of back to the team science thing. In the end, what we did in that committee was essentially some version of team science, where we tried to reconcile the findings from these different studies and looked at which ones we thought were credible, which made reasonable assumptions, which ones had better data that was informative about these problems. In that case, the result kind of was essentially negative, that we didn't think any of these studies, other than the study I just mentioned, which was only partly relevant for the topic, but that none of the studies that directly looked at the effect that people were most interested in, the effect of future crime of having the death penalty, that none of that research was really credible, even though many of the original studies claimed very specific effects with great precision. So let me wrap up here to kind of make sure we have time for the panel and for discussion here. So while I think that the situation is more serious than what Cass Sunstein seems to think, I do think we've made a lot of progress in dealing with the credibility problems, and I think some of the suggestions in the earlier presentations have the potential of improving things even further. I do think insistence on pre-registration will help with some of the behavioral economics experiments where there were particular striking problems. I think having replications and more data available will make it harder to do poor science or make up data. But clearly more needs to be done to ensure that science recovers some of the trust it has lost in recent decades. Thanks very much.
So this was very dense in terms of information, and it was a choice of us organizers to have you to give you the opportunity to engage with the panelists, and of the panelists to engage with each other. And before I open that panel, let me tell you a little bit about the title of this conference. Remember, it was Debating the Facts. And the idea was, well, what is there to debate about facts, right? Facts are facts. But with all of this evidence that you've seen passing in all of the talks, I started to realize that there is indeed a distance from the sample to the evidence, and a lot of researchers make different choices. And I have a few questions that I'm going to ask the panelists, but hey, I really want you to ask questions. So start thinking about your question. And I'm already asking you now, if you ask your question, give us your name and affiliation, so that would inform the discussion. But I'll start with the questions. And before I ask the first questions, I'm going to show you a video that we did for the for the project I did with Anna Dreber and so many others. And this was the first time where I thought it's hugely expensive to invoke a creative agency and create a video summary of your paper. We typically have to summarize our paper in an abstract of less than 100 words, but those are words, and current times people read, but maybe more so people see things, and so we decided to try and give you the abstract in video material of that paper that we did on the multi-analyst study. So can we see the little video? It's only
non-standard errors. Before introducing non-standard errors, let me remind you about standard errors. In statistics, samples are random draws taken from a population. Therefore, statistical estimates can vary. The resulting variability in estimates is known as standard error. I will now introduce a new kind of error: non-standard error. Suppose the same sample is given to multiple research teams. Each team can make different decisions along the analysis path. Because there's no standard path, estimates are likely to differ across teams. The resulting variability is called non-standard error. An experiment with 164 research teams showed that non-standard errors can be sizable. But teams redo their analysis after peer feedback. The experiment shows that peer feedback reduces non-standard errors by more than a half. However, non-standard errors remain substantial. They are at least as large as standard errors. So, next time you see a single estimate, note that it comes with not one, but two sources of uncertainty. Standard error: how different would the estimate be if another sample were drawn? And non-standard error: how different would the estimate be if another team did the analysis?
So this is the video summary. It's like less than 2 minutes, trying to focus on the core message, stripping away all the details. And my first question to the panel, and none of you, well, you did touch it, but I'd like to hear more about it, is this notion of AI-powered scholarship. So Guido talked about AI and what it would do with workers, but let's take the AI, the large language models, to our own profession in science and think about what world we have landed in and how it will change science. And 2 weeks ago, I was at the conference of the European Finance Association in Paris, and I was sitting in one of the sessions, and there was research presented by Robert Novi Marx and Mikhail Velikov. Mikhail actually presented it, and this was the title of the talk, and it was sort of a proof of concept. So what they did was essentially, in some of my field, in asset pricing, people look for anomalies. Once you find an anomalies, you motivate why it's interesting, why this is an anomaly from theoretical research. Then you do the standard battery of tests that people typically do. But it doesn't stop there. Large language models then allow you to write that paper. And for each anomaly the computer or the bot finds, it will also, it writes a complete paper, it will write a nice abstract, it will also find a nice catchy title. And so for each anomaly that they let the large language models find, they even wrote 3 papers. And it was, so the authors have 288 papers published on their website, and they were somewhat conflicted on whether to open that up to the Google search engine, because it cited their own work a lot, and if you have 288 papers cite your work, you shoot up the rankings in terms of citations. Now, the most interesting part was the discussant, and this non-standard errors project that Anna and I did. One of the messages that I take away from it is that when we start to engage after we did the first research with each other and discuss, you can actually find some convergence, and it won't be zero, but you find some convergence. And And so it's one of the ways we do that already is that people discuss papers. And there was a discussant at this conference that he admitted he didn't read all the 288 papers, but he sampled a few, and he said, "Wow, it's amazing what these LLMs can do. These are hard to decipher as AI generated, and maybe they won't pass the filters of the very top journals just yet, but they're incredibly close." And so I'd like to open up with this question: like, given this evidence and this study in particular, how do you see the field go forward, and what is the role of large language models? Is this an opportunity? So one thing this discussant said is actually an opportunity. He started saying, "Well, sounds like we shouldn't be doing this. It doesn't feel right to be doing research this way." But then again, he said, maybe it helps us find that convergence, because the bots, the large language models, see what all reasonable analysis paths are, and will let us know what the robustness is of a particular finding that we stumbled upon. So, do you have any thoughts about this long-winded question?
Sure. I think so. Overall, I think it's very interesting, and I feel sort of the AI hasn't really gone very far in economics research yet. And it is somewhat the same kind of with the machine learning, where people have used these things to do slightly better for things that we already knew how to do. And I think this is a much more creative way of using these large language models. And there's two other instances that I've seen that I think were very creative. There's one paper by researcher Suk-Jin Han, who was visiting Stanford last year, who had written a paper where he was trying to use the AI to come up with identification strategies. And so he was asking it, so one example of what he did was he would ask it to come up with good instruments for studying the effect of education on earnings. And so he kind of had these very elaborate prompts, kind of saying that he was interested in finding a variable that affected how much education people would get, but not directly affect their earnings. And then he asked it to give me 10 of these variables. And what it came up was very impressive. Sort of out of these 10, there were a couple that were kind of just wrong, they were stupid. There was one that was really using an instrument from a David Card paper, so it was really just plagiarizing David Card. But then there were a couple that were actually good. And so if a graduate student had come to me with those suggestions kind of after a day of thinking, I would have been very impressed. Mm. And so, and that type of research is what we typically kind of think of actually what we do. We kind of need to think about these identification strategies, and you come up with new ways of analyzing the data, and having these large language models do that seems very impressive. Second example was there was a particular paper by some, I think, political scientists at Stanford, who used large language models to create a bunch of artificial humans, and then did experiments on those humans where they gave them some treatment and put the others in a control group, and then analyzed the outcomes. And then they also did these experiments with real humans, and the correlation between the true effects in the LLM experiments and the true effects on the real humans was incredibly high. So adjusting for the noise, the correlation was 0.8, which seemed incredibly high. Now, it turned out it was not quite as good, because these were really stupid experiments where when they asked experts what the result of the experiments would be, they could also predict what the result was going to be, and the correlation was kind of similarly high. So these were not experiments where we didn't really know what to expect, but still, they did it quite well. And if we could actually do experiments on synthetic humans and figure out answers to questions where we really don't know, where experts don't know beforehand what's going to come out of that. That would be incredibly interesting. I'm not sure I don't think we're there yet, but certainly these models are getting much better very fast. So I think we need a lot more research of this type, where people are doing very creative things with these things. And what to do with these 280 papers, I don't know.
Anyone else wants to comment?
I mean, I would be a little bit worried about replacing the humans, human participants with AI, given what Naomi was saying, for example, about like we would expect there to be differences between weird, wild countries, Australia, the Netherlands, depending on what we're studying. So I would be very hesitant about extrapolating that type of result. And then as someone who does the experiments online, and as we could see, more and more people do so, I'm increasingly worried about, like, are these humans or are these just bots? Right, and that's that's a real worry that we need to consider right now. And so, yeah, but I'm related to what you were saying about your students. I think we need a system where we sort of reward transparency. If everyone is using AI in their research, we want it to be disclosed and not hidden, so we can understand sort of how has it influenced things. And then I see more room for like identification things than mimicking human participants.
Yeah.
That's my take.
Yeah, I also think it's kind of unavoidable because AI is so good nowadays that as long as you remain firmly in the driver's seat as the researcher, it's just incredibly useful. I've had, just before I came here, I had 2 hours of conversation with the AI on a particular mathematical problem that I'm working at. And it gives me all these new insights. It can do the derivations. I don't understand a certain step. I say, can you please explain? It explains with the derivation. Sometimes I give it an equation and it says, oh, I think you missed a square root here. If I assume that you did the square root, it all works out like this. And it's just like really efficient. And it's actually almost miraculous that it can do that, given that it's a large language model, that it's so good at the derivation. So I'm just a big fan.
Right.
Can I comment? I think a lot depends on what type of question do you use it for and what type of study do you use it for. And so I would be in favor of being very critical of when it might be a helpful tool and when it might not be a helpful tool, but also the scarce resources that we have as researchers, what you want to use them for, also taking into account the cost of using AI for environment, for water use, for energy use, and to say, okay, perhaps you need it for some goals, and it's useful for some goals, but I would be very much reluctant to say we should use it indiscriminately, or we should use it just to play around with stuff, or because we're too lazy to do stuff that we could do ourselves. And in particular, relating to my topic of research, moral behavior, I think there is also a bit of a danger involved there. So last week I was in a conference for moral psychology, and one of the speakers there was working with a group of people who were using the language models to learn about morality or moral judgments. And they used a particular model, John Haidt's moral foundations model, where they extracted certain words, care or empathy, to categorize particular behaviors as moral or less moral. There were 2 things actually coming out of this talk that stayed with me. So one of them was that it wasn't so easy always to get the right outcomes. So that's a kind of validity issue, that the human coder would code it differently than a language model, but that could be learned eventually. But I think the bigger problem is that also talking with the people who developed the code for the language learning, they invested in teaching the model this particular model of moral psychology, and this is what it could do. But the people who programmed this don't know a lot about moral psychology. They know a lot about programming. So if somebody comes along and say, oh, we know, what can we do about moral psychology? Oh, here's this model that we developed. And so at what point would this model or the way it was programmed take over the definition of what is moral, instead of, somebody being able to say, well, there are different models. There are different ways to think about these issues. This is just one type of theory or just one type of approach that was included in the language learning. And so I think that's even a bigger problem, that we confuse the operationalization of the language model with the thing. So we have a conceptual problem, right? The thing that we're after is the morality of the decision making or whatever, and we use one coincidental approach to that feeds into the model. It's being invested in the programming and the learning, language learning, whatever, and then that's the definition of morality. And I think that's the bigger problem.
Claron, is AI and music performers?
It's a problem. It's a problem because what's happening now is this question of creativity and intellectual property. Because I've been being asked more and more to be involved in projects where they say we want to basically sample every single sound you make. We're going to feed it into this, you would call it an AI model, I guess. And then it is going to improvise, or it is going to create something based on what is fed into it. And it's usually being discussed by, I would say, people who are more programmers than creative people. And so if that machine spits out something that's me, basically, is it me, or is it who owns that? Where do you start with this discussion about creativity and ownership? So that's becoming quite a big issue now.
Yeah, understood. I'm gonna look at around the room. Please let me remind you that there's. Tell us your name and your affiliation, and wait for the microphone. This is the hardest part. People typically. Let's start from the back. Why not? Today we start from the back. The gentleman at the back. Please keep your questions brief. Not as long as I did it.
Yeah. I'm Tim. I'm a student. I study philosophy and economics. Thank you so much for all being here. I really enjoyed your more critical approach to what I would say is more an empirical approach to science. But does this for you also translate into being more critical of the role that empirics has in science in general?
Is there somebody you in particular asked the question to, or the entire panel?
Well, since I engage with economics, maybe the economists a little bit, but in general.
Okay. So who's the economist here? Guido, why don't you?
No, so I think the economics has become much more of an empirical science these days. So, and from my perspective, that's been a very effective and good change. I think there's a lot more data available these days, and you see kind of both in government and in the private sector that people have gotten much better at incorporating data in their decision making. So I think overall that's a good development. I'm not sure that's completely answering the question, because I was sort of slightly unsure exactly what the direction of the question was here. I mean, you want to elaborate a little bit on
Yeah, so maybe from what I gathered that you seem to be saying, there was this question whether, or the validity, or how factual can we actually consider these empirical outcomes to be, and this critical approach could also lead in turn, I would say, to a shift away from this type of research.
Yeah, I'm not so worried about that. I think again, I said I work with some people outside academics as well, and I think in general they see these concerns about debating the issues we're discussing here and debating the facts. They see them as less relevant to the way they make their decisions, where the bottom line is that they have a lot of data that are helpful for making good decisions, and that makes things very effective. To just give an example from this course, I was teaching on on data science and sustainability. So there's been a big problem in California and kind of the West Coast in the US in general about the forest fires, the wildfires. And so one of the causes there has been the electrical lines kind of leading to the fires, because there's not enough room between the lines and the trees. So the lines come down somehow and they ignite fires. And so what PG&E has done now is they have a whole, they used to inspect these lines in person. And nowadays they have drones going over these lines, and they use the data to predict where it's most likely that there's going to be problems with the lines. They take pictures, they analyze them, and it's incredibly effective in preventing problems with these lines before they occur. And so there's sort of no issue there that, are these outcomes the relevant ones? The bottom line is that they bring down the number of incidents with these lines way down in a way that's directly leading to fewer wildfires that are caused by line failures. And so some of these things are not an issue there, because the measures are very clear.
Maybe then a next question. I was giving you the microphone. Yeah. I hope it's on.
Almost.
Yeah.
Yes.
Yeah.
You're from the US. We have the political.
So can you start with your name?
I'm Jasper. I'm an entrepreneur
that's
myself.
My role.
What?
That's my role to ask you to start
with
your name and affiliation.
I forgot. I'm Jasper. I'm an entrepreneur myself here in Amsterdam, working on the climate field for the built environment. Interesting times on this subject. We have elections here next month. You're from the US. You have here your President Trump stepped down of the Paris Agreement. He talks also about in election times the same happens here. Right to the far right is we have alternative facts. The first time I was reading this subject today, debating the facts. If we have alternative facts, so we agree that this floor is brown. He said, no, I have alternative facts. This is not brown, it is red. If you think about this on a political arena, we think about your educational backgrounds. What kind of role can education play to deal with this kind of way of debating the facts? And AI is one. 2, AI is not falling from heaven. It's made by humans. So if we create it and we want to change it, we can change it. So also the shit in, shit out. Is it complete or not? It's all crucial things that if we work with it or we take the outcomes for granted, what are the biggest risks?
So I guess the question is debating the facts. How do we? It's sort of related to something that I've been thinking about. Like, how can we discipline a debate where everybody's coming with their own facts to the debate? Is there a way of doing that?
Yeah. So perhaps it's not directly relevant, but I think it is relevant. Also, when you think about politics or policies, organizational policies, you can also think about is that a lot of the time people act or make decisions based on implicit beliefs about what humans are like or how they think or how they might behave, so that deterrence will work or people will make rational choices or people will make cost calculations. And what I think is lacking a lot is the willingness to specify ahead of time what are you going to expect from this policy? What would be a diagnostic outcome to see whether your policy is effective? And are you willing not just to implement the policy, but also to monitor this outcome? And so not just to look at the facts that are already there, but to say, okay, if you commit to a policy, regardless of your political flavor or whatever, regardless of whether you're running a country or running an organization or whatever, if you're willing to say, okay, I intend to do this to achieve that, and this is how I can measure whether that's true, and then keep track of the facts and test yourself and make a record of whether your choice was a good choice or not. And I think we are lacking a lot of that. So we're debating a lot about what we should do based on the facts and whether we can rely on the facts. And one way out of it, I think, would be to commit to future facts and make a record. And we don't do that a lot. And all kinds of places where you think they should keep records of what they're doing or they should commit themselves to a particular outcome. This is not how the policy is developed. It's often based on beliefs or ideology, and there's no specification of facts that could prove or disprove the validity of the policy. And of course, that's partly a choice, but partly it's also, I think, lack of discipline, and we can fix that lack of discipline, we can fix.
There is a question over there.
I think it's René Bekkers, Vrije Universiteit. I think it's related to both questions that were asked before. It's on communicating the unreliability in our science. So if we are open about the problems that we have in, fraud and everything that we heard about today, how do we avoid that? People hating science will take it and discredit our work.
Good, yeah, very, very good questions. I think many of these, at least that's how I interpret the types of projects that I've been involved in or been a consumer of, is that sort of the scientific methods work great. I mean, we're finding out some results do not replicate. Most of the time, I don't think it's fraud. I think it's good researchers trying to do good things, and then you fool yourself along the way. I mean, if you read old statistics textbooks or like Econometrics 101, they talk about sample sizes of 30 in between subject studies. That's how many people were taught. Now we know we probably need more. Like these types of research and degrees of freedom. I learned matrix algebra in econometrics. We never really talked about all the tests, all the different ways you can get the statistically significant results. I think there are low-hanging fruits. I think things are getting better. And I think we can emphasize that more. Maybe I didn't do it enough during my talk, but I think in general, like all of this shows that it pretty much works. But it would take some time, and we can speed up the process. And I like what Naomi was saying. Like we are reviewers, we are editors, we are authors. We're all responsible for this, and should sort of reward when people express uncertainty. Most of the time, we want like a very catchy story. Someone should do a study of like economics papers or scientific papers in general. I think narrative has just increased in power. Like tell a very good story. And I think that's part of the problem. Maybe papers should be a little bit more boring, or like explicitly say this is exploratory. Like because as I said earlier, I like pre-analysis plans for my own work. If other people don't want to use them much, okay, fine. I think they're helpful for the type of research that I do. But a big worry is that if everyone thinks that you need the pre-analysis plan and you cannot deviate and you cannot find out anything exploratory, then we're in a bad situation, because the exploratory stuff, by definition, is basically the things we didn't expect and should learn more. But that should not be the title of the paper. So I think we're still getting there and figuring out how do we do research where sometimes we want to have pre-analysis plans, sometimes not, and we want to have unexpected things, etc. But it's very much sort of work in progress, and a lot has happened in short periods of time. So, and coming back to the role of theory in that vein, I mean, economics is theory-driven, yet our theories often are not so precise in terms of actually giving us predictions. So just having more theory is not the solution, but it's good with some theory, and ideally that is testable. And if you have a paper with a theory and empirics, I want the theory to actually have written before the empirics, if it's presented in that sequence in the paper, which it doesn't have to be, right? It could come later. So.
There was a question over there.
Hello, my name is Hong Tong Wu, former physicist, now actuary and entrepreneur. So I see both worlds. I have actually a question about the econometric scientific environment. I mean, it seems there's a pressure to publish, and maybe to disapprove something is maybe not less incentivized. I mean, it's less valued. Maybe, I don't know. So I was wondering, I was actually asking to the econometricians, what do you think is what prevents you to, what are our incentives or pressures which doesn't stimulate the credibility. And I would like to ask the social psychologist about how to solve that.
Yes, there's pressure to publish. I mean, that's sort of we have a job, we teach, we do research, and we're supposed to disseminate the research we do. And so we there's essentially a marketplace for ideas, and people try to come up with new things and interesting research, and the journals kind of play a role in deciding what research the community as a whole thinks is good research, and we try to incentivize people to do the good research. So I don't see anything wrong, kind of, in particular, kind of with the being pressured to do the research. That's sort of the job we signed up for. At times it gets out of control, and I think there's certainly concern that economics there's a lot of power concentrated in a very small number of journals, more so than they used to be, and more so than in other disciplines, and that's probably not good. But beyond that, I think, kind of in general, the journals try to do a good job in making sure that the publication process works well for the profession as a whole.
Yeah, and a little bit of the spirit, maybe Eric-Jan, you have something to say about, was I understood the question also to mean, like, what are the incentives to do the 500 words in the single graph and produce something for you, right? I mean, was that also part of the question? Yeah, so Eric-Jan, what is your...
Well, for that specific case, there's a tremendous incentive, right? Because as a methodologist, when you are told you can use your favorite method and you only need to write 500 words and you get a publication out of it, like, that's incentive right there. And actually, when we've been involved in setting up many analyst studies, and I think Alexandra knows for sure, but there was one project that we did. I think we had a question: do you want to do a reanalysis or an analysis of a particular data set? I think we had over 100 teams sign up in a few weeks. Right? Yep. So it's clearly something, because it's kind of easy, right? You don't need to collect the data. It's already there.
So I see the point about little effort. I see that point. But there is also this, and the way we work currently is that we need to publish high-impact journals. Yeah. So now I'm trying to think, like, how could your journal become high-impact? I'm thinking if you have a significant debate, you show that something that lots of people see is not as robust as the single study pretends, then people will start citing your journal, and that will create... Yeah. Is that a leap for the journal? Because that's important too, right?
I think, if the robustness reports are specific to high impact papers, right? The original paper in a high impact journal may be cited a lot, but if there's an interesting robustness analysis, that will sort of tag along in the citation count, definitely. Right. But I think more to your point there, I think the trick here is to align the interest of the individual researcher with the interest of the field, right? That's what we want. And I think there are several sort of ways to do this. And if I may channel Chris Chambers here, he would say registered reports is one way in which you can do that, right? Where you, what you have all outlined as an example, you have your plan reviewed. And then when the plan gets accepted and you collect the data and you do a good job with your data collection, the article is published regardless of the results, right? And that, I mean, it's still a lot of work, but it's one way in which somebody at least can be certain of a publication when they do their initial theoretical work well.
Understood. There was a question over here.
The psychologist was also asked.
Sorry.
I'm also a psychologist.
Because I slightly disagree with the previous speakers. You say we need to publish in high-impact journals. You say people are incentivized to get published. I disagree. The people who I work with are incentivized to solve important problems. The fact that you need to publish in high-impact journals, that's something that we make up. When people apply for a job in my lab, I'm not so interested in how long their list of publications is or in which journals they published. I'm interested in reading what they have been doing, whether I think it is original, whether it contributes to the problems that we're studying. So I think this is also a narrative that we make up by ourselves. And so nowadays, when you submit to NWO, you're not allowed to cite the impact factor of your journal. You're not allowed to give your number of publications. You're not allowed to give your age factor. You are supposed to write about something that you did or discovered or contributed and why that made a difference and how you can document that it made a difference. And so I'm thinking, even now with the digital availability of text, it's no longer the case that, if you don't publish in a journal that everybody subscribes to, people cannot find your work. People can find your work online. You can refer them to it. People can disagree with it. So I'm thinking we have a lot of opportunities to escape from this power of the few journals, and we have a lot of opportunities to be very democratic about what gets out there and who can reflect on that and who can respond to that. We have a lot more opportunity to argue for what we think are important ideas. In my case, some of my best ideas are published in the lowest impact journals because the data were not so clear yet, because it was a new idea, it was partly still exploratory. And I think now we have the opportunity, to present ourselves on the basis of what we think are our important contributions to the science that we're doing. And that's the intrinsic motivation I would like to speak to when I'm thinking of, who to recruit or who to hire or who to reward or who to incentivize. And it's in our power collectively, if we are not satisfied with the current system, to change that. So I'm not accepting that you have to, people want to get published. Why do they want to get published? Because we tell them that this is important. I don't agree we have to publish in the high-impact journals. That's something that we have made important for ourselves. We can also decide to make something else important, and we can decide to change it even in our own labs. And that's what I'm trying to do. And so I think there's also a psychological answer to this question.
Very good. So, Claron, you disagree? Does this mean
No. This
you agree?
is people who don't hear so well.
That was one of those blocks.
They say yes, they agree.
Okay. All right, there was a question over...
Sorry, I was now here in the middle.
Oh, in the middle, yeah.
Peter Visser, I've studied biology, had 20 years environmental consultancy, and worked 25 years in politics administration as an interim manager. And my whole life I have to tell people to distinguish between correlation and causality. Only the third speaker did. You say scientific relevant, or statistical relevant, and then in general you mean correlation. But who cares about correlation? It's an interesting departure point for a better research question, but it's not the end. You were the one who is distinguished between it. And particularly in politics, you constantly have to tell it to people. Correlation is not the truth. If I shout now, the leaves will fall down this autumn. Correlation will be 1 or 100%, how do you call it? Causality, 0. And that's for me something, if you want to strengthen the credibility of scientific results, please distinguish much more between correlation and causality.
Okay, I do have an immediate reply here. I think this is why God invented the experiment. So when for observational data, I completely take your point. But if I want to know whether there's a particular causal factor, and I'm able to set up an experiment to test whether, then I can actually hope to get at that question. So for observational work, fine. For experimental work, within the context of the experiment, right? Not the real world, but within the context of that experiment, I think I can get at the causal question here.
I was triggered by the word fact you use. So before you call it a fact, please see the causality also. I was triggered, of course, by the easiness of which you use the word fact. A fact is only a fact if the causality behind this is right. And particularly in politics, that's something, and nowadays especially, you have to fight against, because alternative facts are the same as real facts are not facts. They are what we think is the most strongest explanation of the experiment we have done. You seem to understand what I mean, I hope.
All right. I think we have time for...
May I say one thing?
Yeah, of course.
Just also something that has been coming in my mind, and I want to say it before I forget it, that, and now it's gone.
It will come back.
No, it's about, this idea of what is a fact. So often I'm talking with people I know, and we're just about to get into the biggest bottle of wine and the biggest discussion about, how we're going to address what's going on in the world. And a term like peace or feminism. And everybody's jumping in saying, yes, I'm a feminist. Yes, I want peace. Yes, that person, I'm going, but have we defined exactly what that is? Are we all sure that we all agree that this is what we think feminism is, or peace? So I'm wondering, how do we actually distinguish between what is fact, what is alternative, what is real, what is not, what is conceptual? How can we be more agreeing this is indeed, this floor is red, but somebody who doesn't see colors says it's gray? So how do we distinguish, okay, this is a glass, this glass is this and this, and therefore, or this is what peace means, because it seems in politics we all have there are different ideas of peace, and we will never actually get anywhere if we all say, yes, we all want the same thing, but we haven't actually decided or distinguished between what that thing is, and if we are all agreeing, that's...
Definitions are important, that's right.
And conceptualization and operationalization.
Operationalization. So we're approaching 5:30, and I'm gonna look one more time around the room if somebody wants to ask. I have like 5 more questions. How do we?
Her hand was up a lot. I saw your hand.
One hand was, which hand was up a lot?
The one in the white lighter.
Okay, so that's the last question.
I've been looking at you for like the last 20 minutes.
Very good.
Will somebody please give that person a
the last question. My name is Danielle Timmons, Professor of Public Health Risk Communication at Amsterdam University Medical Center. I like your remark about the observations and other kind of concepts which are not directly related to the observations. But anyway, I wanted to ask a question about, we talked a lot about methodological robustness. That's good. So scientists do a better job, and that's basically it is. But that is about credibility crisis in science. I do not think there's a credibility crisis in society. There's a recent Rathenau report from the think tank of the Netherlands. Trust in science is not declining. If anything, it's increasing. So there is no problem with trust in scientific results. And I think the proof of the matter is in society. Does it solve problems? The theories and the results should be socially robust. Methodological, yes, true, but it should be socially robustness. So you must bring your results into the world, like the real world, like Naomi Ellemers said. And that's the proof of the pudding, and that's where we should solve our problem, so to speak. So, and then we could have different models and different because facts are also a little bit flexible. They fit into different models. We don't care as long as it solves our problems. We should just be talking about that, social robustness. So, what do you think about that, economist?
I think it's a wonderful way to close a panel. Yeah, this is a optimistic note. Credibility is not vanishing. One last thought?
I'm glad to hear that. I think in the US it is a problem, and I think the credibility of science has been declining, or at least I think there's less support in society for science, and it's viewed as less credible than it was a while ago. I do agree that the proof of the pudding in the end is whether things work, whether we make society a better place. But getting there is hard. We can't try everything out in society, and so we first need to do the research, kind of to try and make the case that things actually work.
Can I close? Sounds like a good time to close. I'd like to stay on that. But I have some more good news for you, because if you want to know more about the Rathenau Institute, and this was what was just mentioned, there's another symposium organized by the KNAW 24th of September. It's on the website. It's called Vertrouwen in de Wetenschap, so trust in science. So be there, 1400 to 1700. It's again here, and you can register on the site. Two things I'd like to close with is KNAW has already spent considerable time and effort and resources in thinking about the integrity of science. There's two reports I'd like to flash out. In 2013, Responsible Research Data Management and the Prevention of Scientific Misconduct, and in 2018, Replication Studies. Actually, it was about replication studies, improving reproducibility in empirical sciences. And one quote I'd like to take from the 2013 report, which I liked a lot, was I'm reading now literally from the report. Finally, it is a privilege to be a scientist. Let us work together to ensure that our profession remains enjoyable. As I have already indicated, and this is the president who writes it, the president at the time, as I have already indicated, we should do so not by agreeing on more rules, but by concentrating on responsible research conduct. I think that's a wonderful quote. I hope you will join me in thanking all the speakers. And after the panel, there's going to be some drinks and bites. So stay with us and enjoy more conversation with the panel and with each other. Thanks a lot for coming.